Excellent. Okay. So let's talk about architecting fundamentals, and then we're going to roll right into a lab, assuming that Michael does not completely take us in to the next thing. All right. First, how far is your organization into your cloud journey? Well, that's a good question. So who can tell me, by the way, how far is Travelers in the journey? What would you, from a consensus standpoint, just type in a chat what letter you think Travelers is at? Good. If any of you had said D, I would have been a little worried. Mainly because, just to say this, any company that has been around longer than 2012 typically is not going to be 100% running in a cloud provider unless they've made that intentional decision. In other words, if the company has been around prior to 2012, that usually means they have an existing data center investment. And so I know you're like, but Michael, cloud got started in 2006. It's like, yeah, no, I get it. But we were still doing the data center straddle at that point in time. Around 2012, every single startup I knew was not using a data center unless they had some kind of security requirements, which is really rare. So for the most part, everybody, companies that were started after 2012 because they didn't buy in data centers, they were all running in cloud. Travelers has obviously been around for a while, so like you're not going to see them get invested 100% in cloud. Now that doesn't mean that 80 or 90% of the workloads couldn't eventually be in cloud, but there's still some things running in the data center. There's still some investments in data center. So if someone had said D, I would have been a little concerned because there's still some data center investment happening at Travelers. Now, as far as your individual teams kind of being all over the place, which is appropriate because some of you are just getting started, some of you running multiple production workloads, some of you are just getting into POCs and prototypes. That's pretty standard, right? That's a standard cloud journey, right? Which is just an evolution. Okay. By the way, that little number in the lower left-hand side, just so you can know how the secrets behind the sauce, what that means is actually they want me to come over here and they want me to pre-warm the 17 labs that we're going to roll into. So what's going to happen is that 17 labs are actually going to start pre-warming. It's going to take somewhere between 5 and 30 minutes. So by the time I finish my lecture, we can roll right into the labs and you don't have to wait for things to provision, which is, we don't want to waste your time. Okay. Okay, so here's the shareholder feedback. They want prototypes on AWS as soon as possible, but our teams have to understand the big picture before they get started. What is AWS's infrastructure? What methods can we use? It's critical we understand how to protect our resources from day one. How can we integrate services with existing applications? What should we be aware of? There's a lot of questions, but right now we need to make sure that we're pointed in the right direction. Now, first of all, just to say this, and any of you who are program or project managers and or Scrum Masters or product owners, why do you need AWS for this? I know I would get shot by AWS for saying that, but like, what do you mean? Why do you need prototypes types on AWS? Like, what problem are you trying to solve by running your proof of concepts and prototypes on AWS? And it sounds like actually they're just doing an exploration. They just want to know what it's going to take. That way, maybe they can know the differences between what's out there on AWS and what they already have inside their data center. But that would be my first question. Are you trying to reduce cost? Are you trying to get more agility? Are you trying to operationally offload? Like, what are you trying to accomplish? That would be my first question. So anyway, but let's move on, right? Written by Amazon. All right, so then here are the objectives for this module. How do we know we're building the best practices? How do we control access to resources? How does AWS function from a physical infrastructure? And how do we control where our resources and our data are actually going to live and run? Like, how do we do that with AWS? Now, right off the bat, right off the bat, I load you up with this horrible diagram, which is really great from a detail perspective, but not so great when it comes to like the amount of information. So let's block some of this off for a second. Okay. Ignore this diagram for a moment. We're We're going to block some of this off for just a minute so that we can just simplify things. Okay. Red is a good color, isn't it? Probably should have chosen something a little more subdued. First of all, and we'll just rope off the internet gateway. Know that Amazon has these geographic collections of data centers. Let me say that again. They have these collections of data centers that are geographically near each other, like Virginia, Ohio, California, Oregon, Sao Paulo in South America, Milan, right? Bahrain, Hyderabad, right? Shanghai, Tokyo, they've Singapore. It's like they're all over. They're just collections of data centers. The collections of data centers are actually called availability zones, and they are like co-located in a region. And so those collections of data centers are all tightly coupled with each other. Tightly coupled, that's not really the right word. They're loosely coupled with each other. And they're like power, internet, and cooling kind of independent of each other because they're separate data centers. So a region is just a collection of data centers. That's all it is. And those data centers themselves are typically referred to as availability zones. So just know that this module has a lot of architecture to it, but those are the base components of how you deploy compute inside of AWS. Is you put it inside of an availability zone, inside of a region. Now, if we strip the rest of this out, because we're going to go over this in detail, if we start stripping the rest of this out, these are just ancillary services, both outside core AWS, like more on the edge, and inside core AWS that do all the things that you need an infrastructure to do. Like to give you an example, here's your app servers as an example. Actually, I am going to switch back to red because that stands out. Here's your app servers, for example, right? Here is your caching server for your database. Here's your load balancer. This is how you get connected to the internet. One of the ways. Here's all your edge networking, including DNS and content delivery. Here's the storage system. Do I need you to memorize all this? No, we're literally going to spend the next 3 days going over this stuff, right? But this is the architecture that you're kind of going to build. And by the time we get to day 3, you're going to say, Michael, I actually understand what most of that is. Maybe not all of it, but most of it. So by the time we get to the end of this 3-day period, you're going to have an idea of what each of these things do. That's the goal. And like, why are the servers stuck in an autoscaling group? Why is there a NAT gateway there? What are EFS mount points? You're going to be able to explain all of this by the time we get to the end. Reminder that availability zones are basically just data centers that sit inside of regions. The rest of this green stuff here, by the way, is just networking. These are just networks that sit inside this availability zone or a second availability zone. But don't worry, I'm going to say that again. I'm going to explain it. I'm going to peel it back. But just know that regions are the overarching location where things are run, and availability zones sit inside of regions. That's where anything with a network card typically sits at, like a virtual machine. Okay, so then let's talk about some solutions here. Like, what makes sense in this particular case? Like, what would cover this? What would support it? So we're going to talk about services, infrastructure, the well-architected framework, and then we're going to have our lab so you can get some hands-on experience. Now, how does this correspond with the questions that we asked at the beginning? So like, which AWS services should I consider and how do I manage them? Like, that's the first question. Okay, good. So which services to adopt? What are the different service categories? How do we build resources for these services? What's the difference between managed and unmanaged services? And what about the services that are more software as a service that have no servers to manage versus the infrastructure has a services that require you to manage the servers? So first, just know that those regions that I was talking about before, which are collections of data centers, Amazon's got a lot of them. Now, I would argue that they don't have as many as their competitors because their competitors have been doing it for longer. But I say that they've got key data centers in really key strategic locations. And so for the most part, you can find it a collection of data centers, a region, anywhere that you need it, particularly, if it's in either Asia, Europe, or North America. These, by the way, there's a thing called a global region map that you can actually find for AWS. And so if we switch off to global region map, AWS. All right. So if we look at Amazon's global infrastructure, they actually have a global map that's interactive that you can look at that will show you where they are located at. You might say, Michael, why do I care? Well, you care because you want your data and your compute to be close to where your customers are, whoever's consuming it, right? And so in this particular case, load up. We've got GovCloud, which most people use if they're government contracts. Here's Canada. Here's Ohio. There's Canada West coming soon. There's Oregon. Here's Sao Paulo. In other words, each of these, by the way, has a certain number of what they call availability zones. So notice that Northern Virginia right there has 6 availability zones. Ignore the rest of that. Don't look at local zones. Don't look at wavelength zones. Just ignore that. Availability zones. This has 6 like collections of data centers in here in Northern Virginia. Oregon over here has 4 availability zones or clusters of data centers inside the region of Oregon. The reason this is significant is that some services operate at an availability zone level, some services operate at a regional level, and some services operate at a global level, which is very few of them, actually, but some of them do. So if you ever want to know like what Amazon has cooking, oh, I didn't know that. UAE? Oh, in Israel. I had no idea they were doing that. Spain I knew about, Jakarta I knew about, Melbourne I knew about. Wait, what is this? Auckland. I think I remember seeing an announcement for that. And I definitely knew about Canada West. So if you ever need to know, like if there's data center nearby, you can. Just know that newer data centers do not necessarily have all of the services that the older data centers do. And new services are always launched either in US East 1, which is Northern Virginia, or what's called US West 2, which is Oregon, because that's closest to where Amazon's headquarters is. Okay. Okay. Questions about Amazon's global data centers known as regions and the data centers inside of those regions called availability zones. Okay. Now, there's a bunch of reasons why people move to AWS. Obviously, they're on a per business basis. So like you know, cost, innovation, operational offloading, compliance, I know one company was forced to by the government to move to AWS, right? There's a number of reasons to do it. Now, AWS does have service categories. So if we go take a look, let's go take a look at, well, not that. Let me log in as a different user. And you may rest assured that my demo account is secured with multi-factor authentication. So I know that all of you were very concerned. They're like, Michael, do you actually practice good security? And I'm like, well, I try to. This is my demo account though. Oh my gosh, my password's gonna expire. See, I even have good password policies. So let's ignore this because this is IAM. Let's go here for a second. All right, so this is going to be a little bit of an eye chart, as if you have to interpret a bunch of details. But notice that there's compute resources. They separated containers out from compute. I don't know why, because they're just a different form of compute. Storage services. Look at all these database services. DocumentDB is MongoDB. Keyspaces is Cassandra. They've got managed Kafka in here, by the way, which is not here. It's actually somewhere else. They got a bunch of migration and data transfer services like application data services, database migration services, server. They have a data center migration service, which is really cool. It's part of the server migration service piece. They've got a bunch of networking stuff that you can use, developer tools of all type. Most of them start with the word code, which is kind of funny. Robotics, blockchain, satellite, quantum computing. They've got tons of analytics, tons of IoT. Just there's a ridiculous number of services out there. Security services. Look at these machine learning services. There's like a ridiculous number. Although whoever named this one, look out for equipment and look out for vision. I would like to meet them because it's kind of a weird name, honestly. Deep Racer, Deep Lens, Deep Compose. There's all kinds of stuff out here. So the reason I mention this is that Amazon does stick them into different service categories, like media services versus front-end mobile applications versus cost management. They try to put them into buckets. You, like me, are never going to learn every single service and its details. Don't get me wrong. I can tell you on the surface what most of these are supposed to be used for, but I haven't used half of these. So, you know, because most of the time you're either working in a role, like I work primarily as an architect and an operations person for teams and businesses going through digital transformation, doing DevOps and SRE and stuff like that. I'm not really going to touch the, well, I can't pick on machine learning because I do machine learning, but I can't, like, for example, do quantum computing. I've never touched that service, or virtual reality, right? And I'm not really a data guy, even though I touch machine learning. So, you know, some of the data services even I haven't even touched before. The important point here is not for you to get overwhelmed with the sheer number of services that AWS has. The important point here is for you to know that there are a ton of services, and you're going to want to look and find if the service is available for the requirement that you have. So that's if you want to use AWS. You don't have to use it for everything. So just know that we're mainly focused on this core set of services: serverless, database, compute. We're not going to touch customer engagement tools. We're not going to talk about developer tools, blockchain. We're not going to do all that. Now, architecturally, architects are typically responsible for planning and designing, right? Researching as part of that planning and designing, and then helping to build, which usually requires you to modify your design as it goes. So sometimes that can be very tactical because you're on the team building the stuff. And then sometimes it can be very strategic because you're an enterprise architect figuring out how to manage large scale technologies for an entire enterprise and move that whole thing forward. So the level at which you do the planning and designing, the researching and designing, and the building and designing is going to modify depending on what level of design you're executing at. Notice, though, that designing prototype proof of concept solutions is really important, because you definitely want to design something that you've touched before. If you haven't touched it, it's really hard to design properly for it to really know how it functions. Here's the sample architecture. We're going to cover all of these architectures in the next 3 days. You're going to know what memcached is. You're going to know what RDS is. You're going to be very clear about what these are all used for by the time we hit the end of this class. Now, here's the odd thing about AWS. Everything in AWS actually centers around this little particular piece, an API. In other words, everything in AWS is an API. In other words, you are actually hitting a structured definition and protocol. It's a set, if you will, a structured set of like methods, endpoints, definitions that allows you to speak programmatically to AWS, either using code, a command line tool that's been converted from code, or a web interface, which is what you saw me logged into earlier, which is really just a product that makes API calls to AWS. So the management console is probably the easiest way to interact with AWS, but its function is not nearly as powerful or as scalable as it would be if you were using, say, like the command line, or if you were using like the software development kit. So the easiest place to start is the console. Second easiest is the command line interface, and then using like a software development kit or CDK, which is called the Cloud Development Kit. Those all deploy infrastructure as code. You know, their complexity varies depending on whether or not you know a programming language or not. just to say this in general, everybody needs to learn how to code, even if you're not ever going to be a feature coder, because everything's heading towards code as the base way in which we interact with things. So just something to keep in mind. 3 ways. Those are the things to remember. 3 ways to interact with AWS through APIs, web console, command line, and the software development kits. Those are the 3 ways in which you access AWS. Let me clear my drawing off. Now in the console, by the way, you can do a lot. The console is a great place to verify things, right? The console makes it easy to learn. It's easy to find new services, to configure services and view service usage, but you can't automate with the console, which is why CLI and SDK trump console almost every time. Now, in addition to the 3 ways we can access AWS, which is the web console, command line, and the SDKs, just know is that when you choose services, some of them are going to have a lot more operational overhead than other services. For example, serverless, it actually stands for invisible servers, like hidden servers, meaning you don't manage them, AWS manages them. But if you run a virtual machine, like the gray stack over on the left-hand side, you're going to be responsible for, like, it's not really the gray stack. That gray stack is actually a hardware data center. But if you run a virtual machine, for example, you're going to be responsible for all this patching, all the installation, everything else. If you run, basically, it has a managed service, you're not going to be managing that operating system. So in this particular diagram, AWS is saying, hey, we're responsible for racking and stacking hardware, power, cooling, HVAC in the data center. We're responsible for server hardware maintenance. We're responsible for operating system installation for the hypervisors that are running your virtual machines, not the virtual machine OS themselves. So that means that AWS is responsible for everything there. In a managed service, AWS takes even more responsibility by taking, in a managed service, they actually take over the operating system. They take managing the database, as an example. They take care of backups. They'll ask you some questions, but they handle all that. All you do is deploy your application. That software as a service model is where everybody is pushing towards. How much can I give to AWS at a slightly increased cost in most cases, like slightly increased, versus me running it and have to managing it myself? Most people want this world. They don't want this world where they have a lot more to do. And instead, in this case, all they're doing is managing and deploying their application. So in like a serverless architecture, by the way, notice that serverless services, like the ones we're talking about here, not these, but the simple ones, they do not operate within a VPC. They don't operate within a virtual network. They just run inside the region, right? You can access the service via an endpoint URL, but just so you know, if you run services at a regional level, they can talk to resources that are inside of an availability zone. So you could put, for example, serverless services here to talk to like the database inside the availability zone here. Wait, which database am I talking about? Well, I'm talking about this database, which I'm about to highlight here. This one, or actually it would be this one since it's primary. Okay. We are going to talk about serverless later in this course because it's a really powerful feature to add to your architectures. One thing that's definitely worth pointing out, if you type in AWS documentation, it will take you to docs.aws.amazon.com. Their documentation is actually remarkably good. It's not flawless. They're moving too fast for it to be flawless. But there is a remarkable set of really good documentation here. So just be aware that AWS's documentation is actually pretty top notch.
Hey, Michael, can I ask a question?
Of course.
So did I hear you say that if you use managed services, that they're not confined to your VPC, they actually function outside of VPC?
Yeah, they function more in your account at a regional level.
Okay, so what does that do to the security boundaries that you might have, or that from an enterprise perspective, an enterprise trying to enforce using VPC? Does that not apply to those then?
No, because it's all API driven. So it's still inside your account and still protected by all the account conventions.
Mhm.
But now there isn't an additional networking perimeter that you have to be aware of. So it actually
Okay.
reduces the security footprint, the vector
Yeah,
of
yeah.
attack. Yeah.
And I didn't know that. So yeah. Okay.
Yeah. Now, just don't get me wrong. In most of the services, you can actually attach a network card to most of the services and stick them like virtually inside your VPC. But like as we were just saying, that then increases the attack vectors because you got to protect that somehow.
Mhm.
Yeah.
Okay, thanks.
Yeah. All right. So documentation. And so that's the end of the first like services discussion. So any questions about, in general, the broad categories that AWS sticks services, the three ways that you actually manipulate or initiate services and resources inside of AWS? Any questions about regions versus availability zones? Okay. So let's talk about AWS's infrastructure. So we're going to talk a little bit more about their regions / data centers, a little bit more about availability zones. We are going to talk just briefly about local zones, which are really just availability zones that are not tied to, or like, I'm sorry, that are not in the region they're tied to. It's a really weird concept, but it'll make sense once you see it. And then we've got CloudFront edge locations, which are really just edge locations. So this is outside of AWS's core network. This is like edge networking. So we already talked about AWS's data centers, right? And how services operate either within a data center or at a regional level, which also has its own data center. So that can be a little confusing as well. But what happens is that AWS likes to take data centers and then tightly couple those data centers together. And then they make collections of data centers. So there could be like 3 collections of data centers inside of a region. But what happens is that if one of those clusters of data centers go down, the region doesn't go down. You just rely on the other 2 clusters of data centers to make it work. Those clusters of data centers inside of a region are called availability zones. Now, AWS uses their own proprietary networking equipment in order to like create high-speed interconnects between these clusters, and that brings them all together. Now, availability zones could be one or more data centers kind of strung together, but remember, they're all tightly coupled. Once they get loosely coupled, they're very distinct and separate from each other. So what this means is that, let's say within, like, I think they're picking on, it looks like it's Oregon there. There's 4 availability zones inside of Oregon, which means there's 4 collections of data centers that are tightly coupled inside Oregon. They're called US West 2A, US West 2B, US West 2C, and US West 2D. The letter at the end denotes the availability zone. Everything before it is the region. So US East 1, US East 2, US West 1, US West 2. Those are 4 distinct regions. If I add letters to the end of those, then I'm talking about their availability zones. So, and remember, these availability zones are designed to be fault tolerant and isolated from each other. So that way, in this particular case, you could like lose an entire availability zone and these 2 guys would still be active and taking traffic inside the region. So it's best practice that in general, you will typically run at least 2 servers, let's say one in one availability zone and one in another availability zone. So that way, if you lose one, you don't lose the service. So if all of a sudden this guy is lost, traffic can still go over here to this other availability zone. How does that happen? We'll talk about that. Notice here, regions are completely independent from each other. There's no connectivity, no data replication, except over the public internet. Now, I say that you can actually go over Amazon's high-speed backbone, depending on what services you're using, like Transit Gateway or VPC peering. Note that every single region here has at least 2 availability zones. So 2 clusters of data centers that are sitting inside of that region. Virginia is the only one that has 6. I believe that Oregon is the only one that has 4, but the rest have 3 and 2. I could be wrong. There could be another one that has 4. Now, why would you choose one region over the other? First of all, governance, legal compliance, security. If you can't run in the EU, then you're not going to do that. If you can't run in the United States, well, you're not going to do that. Second would be latency. How close are you to the users? Oh, I mean, most of my users are in Spain. Well, I should probably move over to Spain, right? Not stay in Virginia. The other thing is my service available there? Let's say I'm doing something fringy like quantum computing. Well, quantum computing doesn't run in every single region. Is it available? And the last, but definitely not the least, is cost. Just so you're aware, every region, there's like, I think for at least the big 3, Asia, Europe, and North America, as far as AWS goes, there's one region on every continent that's 10 to 20% more expensive than others. Let me show you what I'm talking about. So if we go to AWS and we type in AWS simple monthly calculator, by the way, what's the name of the AWS service that allows you to store objects and files onto a remote storage system? Does anybody know?
S3.
Yeah, good. S3 was the second service ever launched by AWS. SQS was the first. So the simple storage service is ideal for this. Well, Michael, why are we looking at the simple storage service? You just told me that cost was a factor for choosing a region. Let me show you why. If we're in Virginia and we want to get a terabyte of storage, that's going to cost us $23. Everybody see that? By the way, in case you ever want to play with this yourself. Okay, now, by the way, notice there's a new version of the S3 calculator. They've been trying to retire this thing for years. But notice it's $23 and I'm in Virginia up here. Now, if I switch this same thing, and actually let me zero this out first. So $23. If I switch this same thing to California and I put a terabyte in here, notice that it went up by what, $3.06, which, by the way, represents a more than 10% change from the previous price. So Northern California is more expensive than other regions in the United States. So people avoid Northern California like the plague because they don't want to pay 10 to 20% more for the same performance and the same horsepower. So unless there's a compelling reason to use California, most people are not going to do it. Something to be mindful of. So cost is definitely a factor in this place. Not just is the service available, not just is it close to my users, not just can I legally run there, but cost is a factor as well. I just want to see this really quick. There's an S3 calc. Oh, this is calculator.aws. This is the pale cousin that doesn't have feature parity yet for calculations. Whoops. Sorry, I got a little button happy there and chose the wrong thing. All right, so here are the factors affecting selection of a particular region, right? Now, in addition to having regions and having availability zones inside of those regions, Amazon has basically availability zones that are not inside the region. So basically, they've just taken a cluster of data centers and they just stuck it near a major city. So it's been stuck near a major metropolitan area. And you're like, Michael, why would they do that? That, my friends, is a good question. Here's why. Let's see. Do I have any speaker notes on this? Let's see. I think there was a local zone link, which would be great to look at. Let's just go take a quick look then. So there's another kind of way that you can deploy your services into what Amazon local zones. Notice is that what they do is you actually deploy into a single set of data centers next to a major city like Boston, Miami, Houston. God, there was others. Los Angeles. I don't know where these are all at yet. But they're kind of like ways of you like getting data even closer to your user. This is mainly for you to deploy applications that are super latency sensitive. If you're like, look, all of my customers are in Boston and I need it to be as close as possible to the users, you can actually deploy into Boston. Now, here's the funny thing. Since it's a single availability zone in Boston, it's not attached to a region. If that data center fails for whatever reason, you have to fall back to Virginia. So local zones are a little different in that they are not highly like orchestrated with other availability zones. Local zones are just out there by themselves, and their sole function is really to make sure that performance is at its highest peak for people around that city, like Miami, Houston, Los Angeles, Boston. There's others. Let's take a look at locations. Boston, Chicago, Dallas. Okay, so these are the new ones that I didn't know about. So Boston, Chicago, Dallas, Houston, Denver, Kansas City. Wow, okay. Wow, they really kicked that up. There was just 4. And now they got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay.
I have a question.
Go ahead, Alex.
So the AWS has edge locations, right? With CloudFront. So why stick something in a local zone with all these restrictions rather than just put it in a regular one or a regular region and just, host your site or whatever it is in an edge location that's closest to Boston?
I mean, frankly, if it was a website, that's a great option, right? The problem is that CloudFront's not exceptional at handling dynamic content. So if it's dynamic content that users need to get a quick response for, and millisecond latency is important, then you need to stick it in a local zone. If it's relatively static content or certain types of dynamic content, then what you're suggesting is absolutely the best way to go. Don't stick it into a local zone. Keep it in a core zone, like a standard region, and just put CloudFront on top of it. So that's the distinction, is that if it's really latency sensitive, millisecond latency sensitive, like dynamic content, it has to go into a local zone if you want to make it closer to the user. CloudFront's not going to really optimize for that if it's dynamic content.
So like an API, for example, would be dynamic.
Yeah, but Alex, it depends on the API. If the API doesn't have frequently changing data, like it changes like once a day or something like that, like it's stock trading information, but not real time, but like just daily, then that might work actually on your API. If it's an API where it's feeding real-time stock information, that's not going to work, right? And so it really is the nature of the staleness or the recency of the data.
Okay.
Yeah.
Thank you.
Yeah, it's a good question. In general, by the way, I would recommend that you go after CloudFront first, and then only go after local zones if you absolutely have a very like specific use case to do so. So. Thank you for joining me on a little sojourn there. All right, so that's local zones. So if we have regions, there's availability zones inside the regions. Sometimes AWS will attach a single availability zone, and they call them local zones, next to a major city. And as you saw, there's now 13 cities, which I just discovered myself because there were just previously 4. So they've gotten really aggressive with that. Amazon seems to be not rolling out major regional data centers as much and focusing more on local zones as a means of supplementing. So real-time interactions, real-time millisecond financial information, multimedia interactions, I don't know if you've heard this term, the metaverse, right? Where it's like real time kind of interactions in these virtual worlds. That's the kind of thing that they're optimizing for, is that kind of thing. If you don't know about the metaverse, by the way, really interesting topic that seems to be emerging more and more. If you've seen Facebook try to rename themselves to Meta, you probably have a little bit of a taste of that. All right. Now, Alex was just mentioning about edge locations, right? Here's the interesting thing. Edge locations are not full data centers per se. They're like racks of servers. And I actually had somebody in my last class who actually deployed them for Amazon. And all they do is really caching and some small compute at the edge. So think of this as a caching network. So if you're running a website in Virginia and you want people in Tokyo to have fast access to that website, and it's relatively static content, like it's not dynamically generated, this is where these edge locations come in. These edge locations will create a copy of your website that all you have to do is turn it on, really. And it will create copies of the website. So if a user in Tokyo tries to get to your Virginia website, the user will actually hit a caching server that's in Tokyo, run over Amazon's high-speed backbone, retrieve a copy of the website, and then from the Tokyo Amazon server, it will serve out the content to the user. This is spectacular because it will create a copy of the content close to the user, and it's really based on the recency or staleness timers that you define. They're called time to live, or TTL for short. So you can say, look, my website only changes once a day. And since it only changes once a day, once your server gets a copy of the website, it's good for let's say 23 hours. So you can imagine this system automatically copies your website out to the world upon request to make sure that when users hit it or interact with it, it's already right there, ready for them to go. So they don't have to go all the way back to Virginia to get your content. They can stay in Tokyo and hit a Tokyo server. Really robust special feature to have. Content delivery networks is not a concept unique to Amazon. There's tons out there: Cloudflare, Fastly, Akamai, etc. Just to know though, if you use CloudFront, you don't pay any extra data extraction charges, right? Or exfil charges. Whereas if you use one of the third parties with Amazon, you have to pay data extraction charges, just to be aware. So in terms of locations, we have regions which contain availability zones. We have local zones which can be attached remotely to regions. And then we have edge locations which are scattered all over. Now, don't get me wrong, there are some edge locations inside the regions, but for the most part, if you were just to throw a bunch of salt on a map, the way Amazon does it is they typically stick a rack of edge servers near every major ISP on the planet. So if Comcast is in Chicago, that's where they're going to stick an edge server. If Comcast is, well, I don't know who they're using in Sao Paulo, but whoever the internet provider is in Sao Paulo, they're going to stick it. They're going to stick a caching server there. So Amazon tries to stick caching servers for edge locations near major metropolitan areas that have a large ISP presence. Okay. Here, by the way, is a visualization of a customer hitting an edge location in Tokyo instead of having to go all the way back to Sao Paulo in South America. So that the caching server is actually going to maintain a copy of that website. Now, to Alex's question, people say, well, what's the difference between a local zone and an edge location? Why would you use one or the other? Basically, the difference is it dynamic content on the left-hand side, like lots of changing real-time information, then that's going to be a local zone. If it's a pretty static set of content and you just need to cache it and deliver it globally, that's where an edge location comes in. With local zones, you can turn on specific services. With edge locations, you don't really have control. You can turn on the service, but you don't really have control about where the service runs and what it does. You just turn on the feature and Amazon takes care of it for you. So there's a little bit more control with local zones also. Okay. Any questions about regions, availability zones inside regions, local zones attached externally to regions, or edge locations and their caching functions? Wow. Okay. Well-architected framework user story. Here we go. So we're in our last section, then we're going to roll into a lab. Okay. So this one I'm just going to skim a little bit because this is kind of a filtering function. So when you're an architect, if you're familiar with TOGAF and other kind of like enterprise architecture frameworks, or you understand like different like design patterns like Ambassador or microservices design patterns. Think of this as a cloud design pattern. Amazon has the well-architected framework. It has 5 pillars. It used to have 4. Now it has 5. By the way, the person who wrote the one for Microsoft is the same person who wrote it for AWS. They left Amazon and went over to Microsoft. So oddly enough, you're also learning Microsoft's framework for Azure because they're almost exactly the same. Little piece of gossip and trivia there. Is it gossip though, if it's true? Anyway, moving on. So the well-architected framework and the well-architected tool is meant to act as a filtering function to have you thought about how to design this for cloud, in particular for AWS. So things like, are you applying security at all layers to create defense in depth? Are you like using things like least privilege, creating, protection against distributed denial of service attacks? How are you optimizing for cost? How are you optimizing for reliability and high availability? How are you making sure that you're optimizing for performance, both operational performance and compute performance? How you're operating for operational excellence, like using infrastructure as code, being proactive on monitoring, like how are you doing that? So AWS has this framework that you can use, and there are white papers written for each of the 5 pillars. It's actually required reading if you're going to take the Architecting on AWS exam. But this allows you, with this particular tool, which will ask you questions about how to minimize system failures and operational costs, follow best practices, how to deliver really on the cloud computing value proposition. That's really what it's driven for. The tool itself, by the way, will ask you questions about an existing workload. Like it's not going to analyze your workload. It's just going to ask you questions. So you just use the tool in the console, and then what will happen is that you can just answer the questions. The answers are stored inside your console, so you can actually share them with a partner or review them with like a solutions architect or whatnot. Okay. Ready for a knowledge check? Let's check this out. First of all, actually, before I do that, give you a little preview on the question. Did anyone have any questions about what the well-architected framework is actually used for? Cool. All right. Knowledge check. What infrastructure as code automation platform deploys AWS resources at scale? This is interesting because they don't mention this anywhere in here, but the CLI, the CDK, and SDKs we mentioned, but it wasn't necessarily a platform or a service. Which of these is a platform or a service inside of AWS?
CloudFormation.
That's right, Anastasia. Yes, CloudFormation is definitely a service. There's actually a service engine. You submit a file, it processes the file, and then it creates the infrastructure based on what it processed. So yes, CloudFormation is sorry, CloudFormation is definitely the answer. Whoops, now you get to see all the answers. CloudFormation is definitely the answer. Okay. Next question. Which of the followings are a cluster of data centers within a geographic location that have low latency network connectivity between them? Which of the following? This is the one that's inside of another one. What is that called? That's right. Availability zones are inside of regions. So remember, an availability zone is a cluster of data centers. There are multiple clusters of data centers, availability zones inside of a region. Perfect. By the way, by the time we finish, you'll know what outpost is as well, because that's something we'll cover. Okay. What are 2 of the 4 factors that you choose when you consider choosing a region to run your services? So we know it's not cost because that's not listed here. We know it's not service availability because that's not listed here. What are the other 2 considerations when you consider picking up a region? Alex, good. So local data regulations and latency to end users, right? Your customers, who's going to be consuming this, right? We want to make it like speedy and fast for them. Okay. What is the primary benefit for deploying your applications into multiple availability zones? Why did I talk about that? What happens? What do you get if one of the availability zones fail if you're deployed into 2 availability zones? Good. Yes, you get high availability for resources. That's exactly right. Okay. Last question, I believe. The principle of least privilege is a principle under which of the well-architected pillars? Is it operational security? Is it resilience, performance efficiency, security, or cost optimization? Yeah, security. That's dead on. Good. Good. All right. We are now at the end of module 1, and now we're moving on to lab 1. Are there any questions about anything we covered on the fundamentals of architecting? Okay. All right, lab 1, we're going to roll into, which has us exploring the AWS API to deploy an EC2 instance. Here's what we're going to do with the lab, right? You're basically going to create an EC2 instance using the management console. Then you're going to create an EC2 instance using the CLI. Then you're going to create an EC2 instance using the CloudFormation template. And this is going to give you 3 ways that you can now interact with AWS. You can also, by the way, optionally, just to switch to the task definition, examine and run a second CloudFormation template. So we're going to run it on the console. We're going to run it through the CLI. We're going to run it using a CloudFormation template. Here's what I want you to do. Okay. So go ahead and log in to webage.quicklabs.com if you haven't already done so. Hopefully you're already there. Now, for me, since I was already here and I actually, let's see, are there some pre-warmed labs? Oh yeah, so 13, well, that's fine because we got more than 13 people. I'm sorry, we got less than 13 people, so we should be fine. As a matter of fact, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay, good. All right, so we got plenty of labs. So now what's going to happen is that for you, when you log in to webage.quicklabs.com, it's going to have like my learnings. You're going to click on that, and then it's going to take you into your lab. And you're going to see something that looks remarkably like this. If you click on Open Lab for Lab 1, the very first thing that you're going to do is you're going to hit this start button in the upper left-hand side. So what I'd like for you to do is I'd like for everybody to hit that start button. And if you don't mind, go ahead and go to your reactions and just click on your thumbs up. So I can make sure that you have all started your lab. Okay. Okay, so once you've started your lab, what you're going to do is you're going to start following. By the way, this is going to talk about all the lab stuff, so you can read this. It's going to take about 45 minutes to complete. So we're going to check in at like a quarter after, right? For the most part. And you're going to start your lab by clicking on start lab. And then what's going to happen is you're going to click on open console, and it's literally going to open the console up for you. So for example, I'm going to click on start lab. Notice it's already provisioned. I'm going to click on open console. Notice that you do have to do this inside of either Firefox or Chrome. So if you're using Edge or IE, it probably won't work at all. Just FYI. If it does work, congratulations, you're one of the lucky ones. And then what will happen is that, and by the way, you don't have to end the lab. You can actually just log in on the other browser and you can go straight to the lab. You don't have to end the lab. Please do not end the lab. If you do, it'll eat one of the account instances, and you're going to have to wait somewhere between 5 and 30 minutes for it to start back up. So don't end your lab if you can help it. Matter of fact, don't even end your lab once you're done. Just let it hang out there for a second. The timer, when this hour and 29 minutes expires, it hits 0, it'll automatically log you out and everything will happen in that particular way. So what's going to happen now is that for your lab today, you're just going to start following the instructions. So you're going to open the web console, and actually I have to log out of mine. Good. It logged me out. That's perfect. Notice here, it gave me AWS student. Here's my password. Here's the account ID. So I'm going to go ahead and log in. For you, it'll probably be automatic. For me, it's not, because I already was logged into another account. All right, so now I am logged into my own Quick Labs account for this lab. And so now I'm just going to start following the instructions. So on the services menu, I'm going to come up here and I'm going to choose EC2. Or by the way, you could type EC2 up here if you want to search for it. And then since I'm doing this all through the console, I'm going to click on the launch instance button, right? So I'm click on launch instances. And then what's going to happen is you're just going to start following the directions, right? Amazon Linux 2 is going to be your operating system. Choose the instance type. The instance type is going to be a T2 micro. In other words, you're just going to start following the recipe that they're giving you. Now, you may not fully understand everything that you're doing at first, but also just know that as you go through this, you can actually like read the description of what's happening. So here's Amazon Linux 2, right? Maybe you don't understand that, hey, we're using T2 micros. What is a T2 micro? If you hover your mouse over it, it should tell you information. But that's what you're going to do, is that this is lab 1, is that you're going to run through each of the pieces here. So you're going to do task 1. Then you're going to do task 2, which is from the command line. Then you're going to do task 3. And then task 4 is examine and run a second CloudFormation template. And that's it. Once you're done, don't end the lab. Just let the timer run out, because it'll shut itself off. But you can close your login window if you so desire. So that's what we're doing until about 11:15, maybe 11:20, is that we're going to be finishing out lab 1. And that's our focus. Does anyone have any questions about either lab 1, our setup, and what we're doing for the next 30, 35, 40 minutes?
Michael, this is Raj. So when I'm trying to open the console, it's asking me to put a username password.
Correct.
And this username password, is it my AWS ID password, like my traveler's account?
No. So on the left-hand side, on the lab instructions, as you can see on my screen, you'll notice that there is a username, there's a password, and there's an account ID. You have your own username, password, and account ID. That's what you stick into the login.
Okay, thank you.
Yeah. And notice that it's going to change every lab, so it's going to be different every time. But yeah, that's where you should see it. Good. Okay. So just from a timing perspective, we're going to run this until about 11:30. What I'd like for you to do, by the way, if you do finish early, which I'm giving some extra time for that, is take a break. So make sure you come back at 11:30. I'm going to be here up until about, 11:15, 11:20. I'm going to take a 10-minute break myself. So meanwhile, just go ahead and work on lab 1. Ask any questions if you get hung up. Ask any questions if you're curious, and I'll be right here to answer them. Okay. All right. I'm going to stop talking and let you focus. So let's talk a little bit, just for about 20 minutes, about account security. So by the way, you can ask questions about any topic at any time. So just because I'm moving on doesn't mean we can't talk about anything we've talked about previously. All right, so we just did architecting fundamentals, and note that we're not going to have another lab until after lunch, and it'll be actually one of the last labs of the day. So, but we are going to talk about account security. We're going to talk about networking just a little bit. Then we're talking about compute, and so that's going to be the remainder of day 1. So here's a question for you. I actually don't know the answer to this. Maybe you do. Do you know how many different AWS accounts Travelers has?
More than 10.
Haley, I would totally agree with that. Way more than 10. I mean, in one class, I saw like 5 alone, right? And there's way more. Most enterprises, by the way, have multiple AWS accounts. When I was the head of containers and cloud, the global architect for containers and cloud at Honeywell, they had like 500, easily 500. And that was just for our division. That wasn't for all of Honeywell. That was just for the digital business unit. So yeah, so most organizations have way more, right? So that being said, the question is how do you do security for that account? How do you do control and security for multiple accounts? Because that's at scale is where everything breaks, right? Like when you start scaling things, which is the same way as like stressing things, either from a performance standpoint or adding numbers, that's when things start to fall apart. Getting 5 people together, not a problem. Getting 5,000 people together, that's a whole different set of logistics there. Same with us, right? Handling 5 transactions a second, not a problem. Handling 5,000, 50,000, 5 million transactions a second, that's a whole different scale problem. So these are the questions we're going to try and answer in this module. Okay, so here's our first shareholder feedback. So they already asked us to figure out how to build prototypes, which we just looked at the ways we can interact with AWS. But then they said, look, the first thing we need to figure out how to manage here is how do we create permission sets? How do we do permission sets for different teams? How do we manage different accounts? How do we enforce compliance in some cases with these accounts? Because, Travelers has a certain standard that we have to follow. The accounts have to remain compliant. How do we do that?
Well,
Sorry, was there a statement there?
the cafeteria, they're opening the deli and the cellar bar.
Patrick?
Salt station, I guess. I'm not sure
you-
what it is. My
you
friend told
letting-
me, it's like, oh, by the way, starting going for the deli and the cellar.
I'm going to mute Patrick for just a second. Erica, were you going to talk? Sorry, I saw that you were off mute also.
No, I was gonna yell at Patrick to go on mute.
No worries, I put him on mute. But I'm glad he let us all know about the deli bar. So it's really good that we're aware. Okay, so we've got our stakeholder objectives, which is how do I lock down teams and how do I grant them permissions? And then how do I lock down accounts? And also how do I give accounts, multiple accounts, access to services? Because you want both, right? It's not just like, you can't access anything. That's not good. So the objectives here are, what are the best practices to manage resources? How do I follow the principle of least privilege, which is what the blue kind of thought bubble is? How do I grant temporary access to resources? What if I want someone to just have access temporarily, or what if I'm granting a service temporary access to another service? Is there a way to do that? And then what's the best way to manage multiple accounts, which is really the last question. Because like, does Amazon have a way for us, if I have 500 accounts, how do I manage 500 accounts? Because those people, I've got people in those accounts managing the accounts, but how do I as an enterprise manage 500 accounts? It's important. Okay. So the main thing we're trying to figure out is authentication and authorization. Authentication says, do I know who you are? Are you who you say you are? Can I verify that? Authorization says, now that I know who you are, what are you authorized to do? So you have to authenticate somebody, and then you have to authorize them to do things. Now, that's mainly for permanent users. But what if somebody needs to be elevated temporarily to an administrator role? What do I do then? What if I have a service that needs access to other services and resources? How do I shift that? So other than Michael Forrester hitting way too many buttons, this is a consistent problem. Don't worry, I'm going to be here for at least 3 days doing these kind of things. There are multiple solutions for how you solve that. So there's security principles, which are basically entities that you assign permissions to. So like user is an entity, groups are an entity. Something called roles is an entity. And to those entities, those principles, we assign policies, which policies are collections of permissions. By the way, not all permissions are allow permissions. Sometimes permissions are deny. Like, I could be like, unfortunately, Patrick is denied access to his mute button for about 5 minutes, right? We could say something like that, right? Now, the other thing is, though, is that most of us aren't going to just use AWS to manage our accounts. We've already got Active Directory. We've got Ping Federated. We've got Okta. We've already got user management systems. So how do we hook AWS into that? How do we federate them? And then, of course, the last but not least solution is, how do we talk about the managing multiple accounts solution? So we're starting a new team. How do I provide access to AWS, a single AWS account? How do I govern that? Well, it comes in 2 flavors. The top one, most of us are never going to see unless you create your own AWS account, which I highly recommend anybody learning AWS uses a non-business email and creates their own account. Because when you create that account, you create it, and the email that you use to create it, that's known as the root user. You can actually log in with that email address. Now, just because you can doesn't mean you should. So even when you saw me logging in earlier, did I show you logging in earlier, or was it a fantasy on my part? Here, let's close this down. Over here, you don't see me logging in as the root user. If I sign in as the root user, it's going to ask me, hey, which of your root accounts do you want to use? And in this case, I would use IT Amazonian. And by the way, it doesn't like me logging in, so it actually gives me a CAPTCHA challenge. Hi, who is this? I don't even know what that is. Is that a 7? That's weird. And then immediately it's going to ask me for my password, and I'm going to sign in. And then it's going to ask me for an authentication code, because I try to be smart about these things and give myself multi-factor authentication, because otherwise I could be in trouble. So in this case, it's this will come in handy. Oh, wait, wrong one. Oh yeah, because I never log in as a root account. I actually stuck the wrong one in. All right. Now notice I'm now logged in as the root user in my account, and look what's happened on the upper right-hand side. It does not list an account. It just lists my name. I know that sounds weird, but when you looked at your account users earlier, you saw name at and then account number or account alias. All it says here is my name, because I am literally logged in as the root user. Now here's the problem with this. The root user cannot be limited, scoped, or restricted in any way, shape, or form. There are no permissions on the root user. So general best practice is that you never use the root user, even if it's just you into the account. So on my account, what I would do is I would actually sign out and I would sign back in, but this time I would actually sign in not as the root user, but as an IAM user. And I have put an account alias so I didn't have to remember my account number. And I have actually put an account alias and called it M Forrester. So I can log into the M Forrester account, assuming that I can actually click the right password. Bear with me just 1 second. There we go. And so now I'm logging in, not as a root account, but as a sub user inside of that account. That's known as an IAM user, Identity Access Management User. That's who I'm logging in as. This is the one that I accidentally stick the wrong MFA in earlier. This is the one that asked me to change my password. Notice in the upper right-hand side, it now says Spartan Sage, which is my username. That's what my son calls me, at M Forrester. M Forrester is my account alias. You might say, Michael, how did you set up an account alias? I'm actually clicking on the IAM service and I'm on the dashboard. See in the upper right-hand side? See where it says my account ID and then it has a little account alias over on the right-hand side? My account alias is M Forrester. I can edit it if I want to. So the root user, you don't ever really use unless you absolutely have to. That is a break glass in case of emergency user. Otherwise, you are going to use an IAM entity, and the IAM entities are users, groups, and roles. Those are the different entities that you can assign permissions to inside of AWS. Now, again, root user, don't use it, right? Notice this cannot be restricted. I don't want to overstate this because it sounds like drama. But I have literally seen a business go under because they did not restrict the use of their root user account. And someone went in and deleted all of their non-production infrastructure. Non-production, not even production, just non-production. And the company was out of business within 6 months. So this is not to be really used for day-to-day interaction. You can make horrible mistakes with the root user. Meanwhile, IAM users, of which you can create a lot of these, you can create IAM users that have similar, if not identical, permissions to the root user. Don't get me wrong. There's 5 things that you need the root user for. I'm not going to tell you what they are. You'll figure them out. But an IAM user is pretty much what every other single user gets inside of an organization if you're not federating. If you are federating Amazon with Active Directory or Ping Federated or Okta, you are not using users, you're using what's called a role. But users are usually assigned to users, and users are typically stuck into groups. And all of those entities can be assigned permissions. So to that end, a user is a principal, a group is a principal, a role is a principal, right? A service can be a principal. An identity provider, in a sense, can be a principal, right? So, and to say this, the services and the identity providers in particular basically get hooked in through roles. So services and users can all assume roles. And you might say, Michael, what's a role? You keep talking about roles. I see it's a hat. That doesn't tell me anything. What's a role do? All right, think of it this way. So I'm a father and I'm a son, like not like the son, but like a son, like father, son. So think of it this way. If I went to my mom and I was like, hey, mom, she's from the South, by the way. And I was like, hey, mom, we got guests coming over tomorrow and your room is kind of messy. And could you make your bed for me and like clean up the thing and all that? Just so you know, she's gotten kind of ornery at 70. She'd probably shoot me, honestly. Or at least I get some back talk. So I'd probably just lose a toe or something, right? She wouldn't shoot to kill, just to wound. And because I don't have permissions to talk to my mom the way I talk to my son, right? Now, don't get me wrong, we didn't negotiate these permissions. That's just the way it is in society sometimes when you're like the dad, right? Meanwhile, if I go to my dad, my dad, if I go to my son and I'm like, hey, son, hey, I need you to stop drinking, maybe drive, get somebody else to drive and, stop acting wild or whatever, because I like talking to my mom, right? Which, by the way, I wouldn't say that to her. But like, that would be weird too, because my son would be like, hold on, why are you talking to me like I'm an adult? Because I'm like 14 going on 30. I don't know why we're having this conversation, right? So the point being is that I have different assumed permissions. Now, here's the catch. I haven't changed my identity. I'm actually still Michael Forrester. I am still the same user that I was before. But when I'm with my son, I have a different set of permissions than when I'm with my mom, I get a different set of permissions. That's what roles are. You don't change who you are. You change your permissions with AWS services. So for example, if I had 50 accounts that I was managing and I was the security auditor and I had to audit the other 49 accounts, what would happen is that in the other 49 accounts, we would create a role that would be a security read-only role. And then what they would say is they would say that Michael Forrester has a user, M. Forrester, could assume a role in each of those 49 accounts, which means I would get permissions to those accounts, but it wouldn't change my username and password. So I wouldn't actually have to have another username and password. I could get access to 500 other accounts, but I'd be using my same username and password. The difference is I would assume a role in that account, another role in that account. That's what roles are. Roles are permission sets that a user or a service can assume or take on to get permissions. So it makes things a lot more simple when you can assume permissions with somebody else instead of having to, I got 500 username and passwords. It's like, oh God, now I got to password policies. I got to reset passwords. I got to do all this stuff. Forget it. Just give them a role. Let them figure it out. Right. So that's what a role is. Now, Amazon likes to say that identity providers and services, all these are kind of like principal entities, but just to be clear, inside the IAM interface, there's only 3 principles listed: users, user groups, and roles. That's it. All those other principles, federated users and services and all that, they all link into roles. So I don't necessarily agree with that slide. There's only 3 principles. Users can be assigned permissions, groups can be assigned permissions, roles can be assigned permissions. You can't assign permissions to a service or to a federated identity. They use roles for that. Okay. Now, last statement, and then we're going to stop for lunch. Policies are collections of permissions that you assign to users, to groups, or to roles. Here's what it looks like. If we go in and look at my user, let's say Spartan Sage as an example, this user actually has a permission policy attached directly to the user, which, by the way, is not best practice, but I just wanted to show you. So this actually policy, administrator access, is actually attached directly to my user. But here's the kicker. I'm also part of 6 groups. And if I look at the administrators group, guess what happens? The administrators group actually has a policy attached to it called administrative access. So I, as a user, not only have administrative access, but because I'm part of a group called administrators, I also have administrative access there as well. So it's like double administrative access, right? Not really. Amazon parses everything once. So it's not like all of a sudden you get superpowers because you've got triple admin access, right? You get admin access once and that's it. Okay. Questions before we stop for lunch? Because I promised I would stop plus or minus 5 minutes before 12. Okay. So here's what we're going to do. It is currently noon by my watch, Eastern time. We're going to stop for 60 minutes, and I usually like to make it odd time. So at 1:03 Eastern, right? Because you're going to remember 1:03. You're like, what do you say? 1:03? That's so weird. 1:03 Eastern, we're going to come back. I'm going to finish this slide. I'm going to talk about networking, and then we're going to do compute, and then you're going to have a lab. So there we go. That's the afternoon. Okay. 12 o'clock. I'll put a timer up. I'll see you at 1:03. All right, see you in a bit. Timer for 62 minutes. There we go. All right, welcome back, everybody. Everyone's lunch was good. Here we are on this fine Monday afternoon. We're going to continue our conversation on identity access management. Does anyone have any questions for me before we roll forward? Anything about regions or local zones or anything around the AWS infrastructure pieces we've talked about this far?
Maybe a quick question about the IAM policies and roles. You mentioned that users can be assigned to groups, and these groups can have IAM policies attached to them. So why would someone assign a role instead rather than just putting in that particular policy in the group? Like, why would you do one versus the other?
So roles are for temporary access. So for example, if you've ever administered Unix or Windows, sometimes when you need administrator privileges, you have to elevate the application that you're using, but you're only going to do it temporarily because you need to make a change and then you're going to go back to a normal user, right? While that's not commonly done when you have access inside of a single account, if you need to go access other accounts, either as an admin or read-only or whatnot, you would still have your user ID, but you would then be assigned a role that you can then assume the privileges for. So really roles are actually not for permanent assignment of a particular set of policies or permissions. They're for temporary assignment of policies or permissions.
Right, which you could do with a group as well, but then every user in that group would take effect, whereas you may want maybe just a small subset, something like that.
Yeah, but like to say this is that would be a permanent change in permissions. You would be changing a group's set of permissions instead of just, for example, giving the entire group a role of which they could assume, and then you could track when they assume the permissions, but also like it would give them a different set of permissions in another account. So the roles are really used for temporary access to kind of, in a sense, other environments or other services, but you wouldn't grant it permanently necessarily, right? You just want them to assume that different set of permissions when they need to do something and keep it down when they don't. So it's an old concept that comes from like the Unix, Linux, Windows world, where it's like, well, we don't want to give anybody administrator access the entire time. Let's just have them have their base set of permissions, and if they need to elevate, they'll assume a role to get an elevated set of permissions.
Right, okay, that makes sense. Thank you.
Yeah. The other thing is that services like EC2 or containers or Lambda can actually also be assigned roles, but they can't be users because they actually exist as services, entities inside of AWS. So roles initially started out not as a way to give users access, but as a way to give services access to other services. So for example, if you had a Python application running on one of our EC2 instances, you could assign the EC2 instance, let's say an S3 role, so that Python application could actually go and talk to that S3 service. Now you might say, well, why would you do that? Because couldn't you just give the Python app a username and password, like a secret access key and an access key, and just let it access it, that way? The problem is that usually those credentials that you give an application end up in a repository. And the problem is that that's a no-no, sticking credentialing inside of a code repository. I've also seen a company go out of business for that as well, right? Where I actually started a company, I won't say how long ago because you could probably figure out who it was. We started a company and everybody who had ever cloned that Git repo had the root account secret and identity access key for the entire production account. So anybody in the entire company's history who had ever downloaded or cloned that Git repo was able to basically access the production account as the owner. So that's another reason to give roles, is because you can assign them to services and assign them to applications, and you don't have to give a username and password, which, or any other kind of credentialing, so that it never ends up in a repository. Interesting thing to ever try. Create a read-only set of credentials, like an access key and a secret access key, post it into a GitHub repository, and see how long it takes for AWS to call you. Because they will actually call you within like 15 or 20 minutes of you posting a credential set. Now, the thing that's impressive to me is not that they are scanning all the Git repos, but that they're apparently doing multi-layer scanning, so they know within 15 or 20 minutes that you have posted credentialing. That's impressive, right? So that's another use for roles, is let's give services a role instead of a username and password, so that way that never ends up in a repository, and it's always environmental. So that way, if your application is running in QA, it gets QA access. If it's in prod, it gets prod access. So then that way the application will derive its credentials based on the context it's in. It's a good question. All right, what else? Any other questions? We just really scratched the surface on this, so we're going to get into it even more.
Yeah, I guess I was always a little bit confused between roles and policies. So where is that line? Because you can assign policies to a role, right? And
Right.
have, depending on what needs to be done.
Well, just so we know, user like groups, right, can have policies that attached to them, which is what we're seeing here on the screen. This is an administrator's group and it's got a policy attached. Users can have policies attached to them, right? So here we've got an administrator access policy. And then roles can also have policies attached to them. So in order for roles to function, has a set of permissions, you have to assign permissions to them. So think of the role as the actual disguise, but the disguise grants you the permissions that you're looking for. So if we look, for example, for M. Forrester, there's an M. Forrester admin role that I created. If we look at what's attached to this, notice that it has administrator access policy also attached to it. So we just saw a user, a group, and a role, all with administrator access policy attached to it. This policy is an AWS managed policy. So it actually says the same thing across all three, whether it's a user, a group, or a role. Now you can change that. So think of a role as another identity you can assume, like an assumed set of permissions, but it in and of itself does not actually have a policy attached to it naturally. You have to attach a policy to it. The other thing that's interesting about roles is that you have to say who can attach themselves to a role. You have to say, all right, I've created this superhero role. It's got access, I don't know, to the Justice League or whatever. And what's ended up happening is that you got to specify who can assume this superhero role. Now, in this particular case, anybody who's in my account can assume this admin role that I have. I didn't actually specify a user, I specified the entire account. And you can see that right here. But you could say, look, the only people who can assume this role is Patrick McDermott. He's the only one who can assume it, right? And then that way, if it's a P McDermott username, he's the only one who could assume the superhero role, right? Meanwhile, we could create a super heroine role for Jasmine, and she can assume that role, right? Not to necessarily a line along those lines, but I think you get the general idea. So to put this in practice, you see how it says Spartan M. Forrester up at the top? If I actually copy my account number and I say I want to switch roles, I can actually put the account up here, assuming that I can not paste YouTube videos. Let's try that again. I wonder why I didn't copy. Let's try it. Let's switch roles. Let's put my account number up here. And let's say I want to switch from Spartan Sage to the M. Forrester role. Oh, caps really helps. And then I can change the color if I want to. Let's say we'll make it green. When I switch roles, notice what's happened on the upper right-hand side. So I'm no longer like Spartan Sage, which is what my username was before. I'm now the role M. Forrester admin. So I've now taken the previous set of permissions, in a sense, set them aside. And now, for all intents and purposes, I'm enforcer admin. But the funny thing is that that's just a role. I'm actually still the Spartan Sage user, because if I try to log in, I have to log in as Spartan Sage. I can't log in as enforcer admin. In other words, a user will allow you to log in and then you can go to another role at that point in time. But you have to initially log in as a user. You can't log in as a role. A role, like I said, is only a disguise. It's only an assumed set of permissions. And then once I'm done, by the way, operating as an admin, I can just go back to Spartan Sage and then notice I revert back to my user. By the way, when I switched roles, I could have stuck any account ID that had this role in there that would allow me to assume it. In other words, the role is in the other accounts, and that role says that my Spartan Sage user can assume the role. So the role entity, the principal, exists in all of the other accounts in which I can actually jump into. And so just so you know, that's where the role has to exist, is in the targeted account that you want to switch to. Or in this case, it's just the same account, so there's no difference. Any other questions? All right. Now, here's the tricky thing. When we federate IAM with Active Directory, and let's say that we log in as an Active Directory user on Microsoft's Active Directory service, like, you're logging into your corporate network, or you're using another service. Let's say it's Ping Federated or Okta or something else, and you're logging in to that other system. There's a trust relationship between AWS and that system. They exchange what they call meta information through a document. And so what happens is that when you log in Active Directory, you actually have assigned roles to those users and groups that are over in Active Directory. So if you log in through Active Directory, oddly enough, you're actually using roles to assume permissions inside of AWS. So like for Web-based solutions, when I log in as Enforcer into our Active Directory service, when I want to get into our accounts, I actually am using an administrator role over in the other system in AWS because I've logged into Active Directory and I am assuming an admin role over in AWS. So these identity providers down here, for example, that are listed, that's a great way to kind of illustrate that, like, I log in here, and then what ends up happening is that it basically goes and grabs a role, which then gives me access to the account. But in green here, these systems, let's say AWS in this case, and the identity provider, they have a trust relationship. In other words, they have a pre-established certified relationship with each other. So just know when you set up federation, you have to exchange documentation with the Active Directory server to make sure they can trust each other, and they, to a certain extent, have to find each other as well. They have to know where they're at. Now, AWS knows where services are inside your account. So they don't have to be authenticated. You know why? Because it knows what's running in your account, and they know what's not running in your account. How? Every single resource you create inside of AWS gets a unique ID. It's a fingerprint ID. It's called an Amazon resource name. That Amazon resource name contains your account number. So every single service that you run inside AWS is fingerprinted for your account. So then they don't have to do authentication because they know if the service is running in your account or not because it's got your account number in it. But what they don't have is they don't have authorization. If you want a service to talk to, say, another service, you actually have to have that service assume a role. By default, everything is locked down in AWS. Just because you create a username doesn't mean you have any permissions. Just because you launch S3 doesn't mean that you can talk to EC2. Just because you launch an EC2 instance doesn't mean you can talk to DynamoDB. These things have to be granted permissions in order to do that. And you can do that easily, but it does require you to do it, right? To show this in action, if we go over to EC2, assuming that I remove all my drawings, if we go over to EC2 and let's see, I don't think this is in Virginia. I think it's in Ohio. Let's go over to Ohio. For example, here's a stopped instance, right? But I can actually modify the security of this instance and make it so that it has other role permissions. Notice that all of these are roles. Jenkins role, right? OpenShift role, because I was working for Red Hat last year. External DNS role, EC2 full access role. These are all roles that I can assign to this virtual machine. What this means, by the way, is that any application on that virtual machine is going to get access to the services specified in this role. So if this role has permissions to access S3 and DynamoDB, any application on this instance will be able to access S3 and DynamoDB. So this way I can actually have the application's platform have the permissions instead of trying to hard code it into the app itself. There's some interesting roles out here. Some of these I don't even remember creating. They were probably part of some orchestrated process. Why did oh, that's right, because I was messing around with EKS the other day. That's what I was doing. Okay. Questions about any IAM entities that are shown on this page? Okay. All right, so users, we've kind of talked about, this would be your administrator. Like, this is any like person that you want to assign a username and password for. Now, once someone's gotten a user account, they can either log into the console, they can log in programmatically, or they can do either or neither, right? So you can control. You can give somebody access to log in programmatically, but they can't log into the web console. You can give them access to the web console, but they can get they don't get access programmatically. So you can control that if you want to. Notice that the root account user is really not used, so we leave that alone, right? Now, when you use a user, you either are going to use the username and password to log in the console, or you're going to use what's called an access key and a secret access key. What is that? Well, that's really just a username and password, but it's just longer so nobody can steal it and remember it easily, right? This is what you use on the AWS CLI and the SDKs to authenticate your access. You might say, Michael, what are you talking about? Because I like to talk to myself a lot. Usually I say other Michael, but it's okay. That's an Archer reference. Okay. So here we are in the command line. So when I type in AWS EC2, let's say I want to describe any instances that we're assuming I can spell instances properly. If I want to describe instances, now notice that on my web console, you just saw that I actually had a Triceratops on AWS box. Because we were just up here looking at Triceratops on AWS box, right? So you never forget those names. So all it did was it just showed me the EC2 instances I have. Now here's the question. I didn't log in. So how did it know who I was? Because I'm on my desktop right here. How did it know who I was? Well, here's the answer. When you set up either an SDK, like you import a library, or you decide to set up the AWS command line, what happens is you actually run a command called AWS configure. And notice it's not showing the existing key, but here's my access key. Notice, see how that ends in PBOH? It ends in PBOH, right? So if we go over here and we go back to IAM, of course, we're like, I love IAM. We go back to my users and we click on Spartan Sage and we're like, hey, let's go to security credentials. I want you to notice, look at what the last 4 letters are for this access key right here. See, it's PBOH. See how this is PBOH at the bottom? Because what I did is when I created an access key, what happens is that when you create an access key, it's going to give you the username, which is what the access key is. And then it's going to give you basically a password, which I'm not going to show you. Because if you're quick enough, you could probably log into my account before I even was able to disable it. Right? So you can also just download the CSV file. Just note that if you do not retrieve your secret access key, when this thing pops up, you'll never see that again. Don't get me wrong, you can delete it and create another one. That's not an issue, right? So in this particular case, I didn't retrieve it, so I'm just going to delete it, just so you know, you have to repost everything. Oh, you got to deactivate it first because I always forget that. And then you got to enter the key ID. Amazon will frequently ask you to disable things before it lets you delete them, just FYI. So now notice this is gone. So all I'm left with is a PBOH. So the access key is here. Here's the secret key. By the way, the other things that ask you are things like, hey, by the way, can I, what region do you want to operate out of? And what's your default output format? Soon, by the way, it's going to be telepathic. So it's just going to beam commands directly into your brain. But right now, version 2.0 is still stuck on YAML. I know it's antiquated, but wait for it. Soon we'll be living in the metaverse and we can all telepathically interact with our command lines. So I'm joking, by the way. Well, maybe. Who knows? So by the way, if you don't see YAML as an option, I am running AWS I'm running version 2.2.10 as the command line tool. If you are not on version 2, you won't see YAML as an option. JSON will be probably your most syntactically available default. Okay, so YAML. By the way, if you love JSON, which I do, awesome. But I just gotta say YAML is a lot more readable, although it's a lot more fragile. Oh, so many lost hours on spaces. Okay, enough of that. All right, so that's to show you how do you set up the command line. You just run AWS space configure, you put in your access key and your secret key. How do you set one up? Well, you go over to IAM, you click on your username and you just create one. That's it. I just want to point out, by the way, there are other keys here. There's keys for code commit. You'll see it here. There's get HTTP credentials. There's keys for key spaces, which is really for Apache Cassandra. Just know that there are more than just username and passwords and access and secret access keys here. There's other stuff, but they're really specialized. So hopefully you won't be messing with anything else. Okay, so once you're authenticated, so once you've either put in your credentials for AWS or you've put it into your code or you've logged into the console, you can do whatever permissions you have. Just that easy. Now, one thing to note about policies, because remember we have to have policies attached. These policies define permissions, is that you can, these are based on APIs. So if you want to describe an instance versus running an instance, you can actually call out in policy that you only want someone to be able to list, get, and describe. Those are the 3 actions, right? And that will allow someone to read something, but it won't allow them to change anything, right? There's no modify, there's no run, there's no delete. So here, by the way, they set it to just describe anything for EC2. Cool. Notice that's the policy for auditors. We like that. Notice for admins, it's just anything. By the way, the meta on policies can get very deep. We run like a 2-day workshop on IAM policies. It can get serious. You can set conditionals, like say, hey, if it's between this time frame, they can't run any commands. If they're not coming from this IP address, they can't run any commands. If the resource is tagged do not touch, they can't run any command. Like you can do all kinds of stuff. It's kind of crazy, actually, the amount of stuff you can do. People have done some really creative stuff with IAM permissions. Oh, Amazon. All right, so notice that the root email, user name and password, we don't really use that. Oops. The IAM username and password is what you've seen me log into, and you used it to log into your labs. And then the access key and secret access key are used for credentials for command line and programmatic purposes only. Why MFA is even listed there as a credential type, I guess it is something you have, so I guess technically it is accurate. 2-factor MFA, multi-factor authentication. So you saw me when I was logging in earlier that I actually had my phone with my keys on it, right? I had to log in using my keys. Just to say this, MFA is pretty standard. I'd probably be pretty careful if you actually put that on your command line tooling, because that can get pretty annoying where you have to submit an MFA ID every time you run a command. Just, that's probably the only thing I would be mindful of. guard those access keys and those secret access keys with your life. Don't let anybody have access to them. They're yours and yours alone. If you're doing it for application sharing, I would seriously ask you to consider using roles instead of using a user access key and a user secret key. So if you're running an application, if it's on AWS premise, try to use a role. If it's off AWS premise, you might have to use a dedicated user access key and secret access key. But Amazon's trying to get around this by creating what's called service roles, and that's kind of an advanced topic, but just know that you might have options to not run an access key and a secret access key, even if you're not on AWS infrastructure. So just keep that in mind. Here's a rehash of the access key and secret access key. Notice it's showing you entering the whole thing in. By the way, that access key and secret access key, if you're not on AWS infrastructure, is required. Like you have to use it for the most part. There are ways to get around it, but only if you federate. So for the most part, you have to use access and secret access keys if you are off AWS. Groups, by the way, pretty straightforward. Why? Because we've been doing users and groups for, God, 30 years now. You know, you stick users inside of groups, you give the permissions to the groups. Person can be part of multiple groups. I have to say, I take issue with these names because most of us name our groups intuitively, like full S3 access for project A, full S3 access for project B, read-only access for project C. Like we name your groups more intuitively than this. Because that's not going to tell you how you're actually supposed to assign permissions, right? Unless the group name is like S3 admins for machine learning division B. Great. If that's your company grouping, then that's probably pretty kosher. Otherwise, I would recommend that you usually name your groups after the permissions that the group grants, because a user is going to be a member of 20, 30, 40, 50 groups on average. So keep that in mind. The only thing that I don't like about groups, I don't know why Amazon won't do this. Maybe it's because of the parsing thing. You can't stick groups inside of groups. It's a little weird because you can do that with Active Directory and pretty much any other system I've ever seen, but they won't do it for IAM. I don't know. Maybe it's more complicated than I think it usually is, actually. And then roles we talked about. Again, reminder, roles are for temporary access only. You like if I'm running around, by the way, acting as an admin, like you just saw me escalate my permissions to M Forrester admin. If I'm doing that 24/7, I might as well just give myself admin access. Oh, wait, I did do that because I was tired of escalating myself into admin, which is why you saw administrator access attached to my user. So my point being is that if the user's just running around 24/7 as the permissions role that you gave them, then just go ahead and give them the permissions and drop the role, right? If they're just doing that all the time anyway, that's fine. If they're actually using it the way it's intended, where they only assume the permissions of the admin when they actually need to, great, then they're using a role properly. Remember, according to AWS, roles are for temporary access. Let's see, we did talk about assuming a role. You actually saw me do it, where you can actually make an API call, by the way, where you can assume a role. And then what will it do is it'll return back some temporary credentials, and those credentials will become your temporary identity, which is kind of cool, actually. And so when you try to identify yourself to AWS, it'll say, oh, you're M Forrester admin. And you're like, wait, no, I'm Spartan Sage. And they're like, no, you're M Forrester admin. Until you drop that role, you are, for all intents and purposes, you are that security identity. It is worth mentioning, because that we're talking about roles and all this other stuff, is that Amazon has a service that's been around forever called the Secure Token Service. Most people don't know about it because it doesn't list itself on the console, but it's the service that passes temporary credentials out to users. So when you need to federate a user or just use a traditional user, it's the one that gives out all the tokens, the security tokens. Yeah. By the way, you can turn on CloudTrail, and I think CloudTrail is the only way you can track it, actually. I don't think there's any CloudWatch metrics. I think CloudTrail is the only way you can actually track all API calls against ATS against STS. Let's see. Policies can be assigned to users. You can assume identity from different roles. So just to rehash this, users, groups, and roles can be assigned policy permissions. That's it. Users, groups, and roles. Those are the three entities. I like this. Think of roles as limited sudo access to AWS if you are familiar with Linux. If you're not familiar with Linux, think of this as the Windows elevation, like escalated privilege, right? What do they call that? The admin whack? I can't remember now. So again, roles, temporary permissions, temporary elevation. Okay, so that was just all about security principles. That was just about the principles of IAM. Questions thus far? Okay. All right, well then what about policies? Well, here's the cool thing. There's really only one way to set up policies inside of AWS. Are you ready? Everyone open their eyes here for a second. It's this one. Identity-based policies are really kind of the official way in which you grant permissions inside of AWS. This is a limiter. This is a limiter, meaning it sets maximum permissions. And just to say this, at last blush, there are only 5 services that I can remember off the top of my head that allow you to actually assign permissions to the service that says which users can get access to it. S3 is probably the biggest culprit. I think SNS and OpsWorks. Actually, I think we're down to 3 now. Anyway, bottom line. Resource-based policies are not really used except for S3, which requires them because S3 is so old. Dinosaurs are still around. I'm just kidding. 2006 is not that old. I hope not, because I have a birthday on Friday. IAM identity-based policies are pretty much the way that goes. What does that mean? It means that policies are attached to the identity and not to the resource or the service. That's the distinction. So identity-based policies get attached to users, groups, and roles. Resource-based policies get attached to services. And again, there's only like, I think there's only 5 services that actually will support resource-based policies. S3 is definitely the primary culprit. I think SQS, SNS, OpsWorks, and there's got to be one more. I can't remember. But so you don't really use resource-based policies. Now, when granting permissions, it says, the same thing I just said. Identity policies are based on users, groups, and roles. Resources are based on resources. Resource-based policies, by the way, are only checked when someone tries to access a resource, obviously. Because until you access the service has no reason to check and see whether or not you should be accessing it, right? Now, here's where by the way, let me just mention this. Permission boundaries and SCPs are ways of preventing people from touching services. So for example, as an insurance company, maybe you're not using ground satellite, the service ground satellite, because you haven't launched insurance in satellites yet. Don't worry, I'm sure that's coming. Something to look forward to. So, so for the time being, you're like administrators for your organization, for all of your accounts, might set up a service control policy that says nobody in the organization can run ground station, which is the AWS service for satellites. And then that way, no matter what they do in their account, in the actual account, not the organization, but in the actual accounts, no account administrator can be like, hey, we're going to use ground station, because the owner of your enterprise said basically that nobody can use it. They might do that for quantum computing. They might do that for augmented reality. They might do that for a bunch of services. And you might say, God, Michael, why would they do that? Just so you know, one, if it's not relevant for the business, they might be controlling that. 2, Amazon adds new services all the time. And just because they add new services doesn't mean you get access to them, because the business might need to assess it from a security perspective costing. Some of the services are not as cheap as you want them to be. So, you know, they're just trying to protect the enterprise. You know, if that bothers you, let me know. You can go work for a startup. I'm just kidding. No one leave the company. So just know that like you want to have limits because you want to control how compliance is run inside of Travelers. Okay, that's why they do it. They don't really talk about that in the slide, so I just want to make sure that's clear, is that these are limiters. So you use them to enforce compliance. Okay. Now that being said, in case you didn't know, there's a term called defense in depth, which basically, you know, Amazon talks about how identity-based policies are really kind of the first thing everybody goes for. There are resource-based policies we can say, look, in addition to having user prevention, like the user may not have access, we can actually have policies on the resources that say, hey, we're not using this. Oh, that's interesting. I didn't know that VPC endpoints had a policy set up. Huh. I'll have to take a look at that actually. Bucket policies I was aware of. KMS I was definitely aware of. I didn't know about VPC endpoints. I knew you could control access. I didn't know it happened through resource-based policies. Good to know. I'll talk about what VPC endpoints are when we get to the second networking module. But the idea here is, how do we make it as difficult as possible for someone to hack and get past all of this protection, this infrastructure? Because remember, the vast majority of hacks are actually internal or by, you know, ex-employees. So it's like, how do we like prevent all this from happening? To date, I don't think Amazon has actually had any strong internal hacks that have led to the compromise of customer data. How do I know? Because I think we probably all leave Amazon, honestly, at that point. But those are the, you're trying to create a difficult road for a hacker to get into a system and get access to the services in question. Because, you know, they're looking for valuable data. Now, there's two types of identity-based policies. There's ones that AWS makes up, and there's ones that you create. The ones that AWS manages, you can't modify them. You can copy them and make your own. But the custom managed ones are like the ones where you're like making your own policies. I will tell you that most enterprises are not comfortable with AWS being in charge of their policy infrastructure. So most enterprises tend to write their own policies for this kind of thing. So don't really know of someone who's like, man, I just love the way AWS manages policies, because they do a very simple job, but doesn't really meet the needs of a custom enterprise. Now, policy has a few interesting elements to it. This one, by the way, principle, and this one down here, condition, are completely optional. But you have to have an effect, of which there's only two options. Are you going to allow something to happen, or are you going to deny something from happening? Now, actions includes the list of APIs that they might have access to, and then resource specifies, okay, what do they have access to? Is it a specific S3 bucket? Is it a specific EC2 instance? Let's take a look at that. Okay, so in chat, someone tell me, is this going to allow something to happen, or is it going to deny something from happening? Right, it's going to allow. By the way, if this said deny, what is the only way for you to ever fix a permission that says deny? What's the only way for you to undo a deny permission? Yeah, I wish it was just that simple, but quite frankly, if someone puts deny into a policy, no amount of allows will ever allow that deny to be undone. The deny actually has to be removed before someone will be allowed in, which is, you know, kind of nice, because it's like when someone says no, until they say yes, the answer is no, right? So, and the action here is against which two services? So they're allowing two services. Which two services are they allowing? Yeah, so Dynamo and S3 basically. And they're allowing any action, because notice there's an asterisk there, right? Which is just a shotgun wildcard. It basically says, look, any API, they can do anything they want to DynamoDB and S3 as long as it's the following resources. Now, ignore the account number without hyphens. That there should be an account number there, but there's not. They didn't want to put an account number. You know why? Because every time they put an account number there, somebody tries to go some messes with it, which cracks me up. Notice it says table/example table. So they're calling out an explicit DynamoDB table. And then notice this little piece of weirdness about S3. You have to grant permissions, not just to the bucket. So in this case, example bucket, doc example bucket, but you have to grant permissions to the stuff inside of the bucket. Just so you know, no other service does that. Only S3 requires you to say that you can actually talk to the container, the bucket, and the stuff inside the bucket. So weird. But S3 is like, 15 years old. So you gotta keep that in mind. Not that it's not modern and hasn't been iterated upon, but for some reason they haven't removed that particular peccadillo, right? So, so bucket permissions and contents of bucket permissions are two separate things. So what this means, by the way, if no one says yes, then you're also denied, because there's an implicit or invisible deny by default. You have no permissions. So the default response is you don't have access. If someone says, well, you have access, that's great. If someone comes in and expresses, hey, you know what? You don't have access. You will never have access until that deny is removed. So an explicit deny trumps everything. An explicit allow will trump an invisible or implicit deny. And if you don't have an allow, then you don't get access. So just remember, an allow is what's required for you to get access. But if there's a deny above that allow, nothing happened. Okay, so here we have a deny, by the way. This is an explicit deny. Notice it's the exact same policy. The only difference is it's like actively a no. Like, no, you can't get access. So this has to be removed before this policy will work. So if you attach both of these policies to an entity, like a principal, like a user, this one would trump this one. So this one would be in effect. Now, in addition, you can actually set up conditions and says, look, if you own this resource, you can mess with it. If the date is between January 1st and December 31st, 2021, you can do your thing. If you're coming from my home IP address, you can do what you want, right? Notice here that in terms of like which instances you can do this with, notice that they're allowed to start and stop instances against any instance in any location, as long as they own the instance. So if they're the owner, they got it. Now, again, just a rehash. Explicitly denied, nothing will ever happen. No explicit deny, but they're explicitly allowed, good, they can go. No explicit allow, then by default they're denied. That's all identity-based policies. The only difference between an identity-based policy and a resource-based policy is this little line right here. Note that everything else was actually in our previous policy. We had effects, we had actions, we had resources. You could add a conditional to this if you wanted to. Principles are the only thing that's added to a resource-based policy. Notice in this case, it's saying, hey, anybody in this account ID can basically access the system.
So you said in general, we shouldn't or don't use resource-based policies?
Yeah, that's correct.
Okay, so it's a previous team, but what do I do if and when someone tries to tell me otherwise? Because I know we, in a previous team, I'm pretty sure we used that a lot. We apparently shouldn't have been.
Well, the problem is that if it's one of those 5 services I listed, you might have to.
Oh, that's true. Okay.
Yeah, like especially with S3. If it's S3, you might have to, because S3 is just wonky. But if it's one of the
Okay.
other services like OpsWorks or SNS or SQS, you might be able to do it in identity-based policies. But with S3 in particular, there are things that you cannot do except using a resource-based policy. And there's no way
Okay.
around it. So they might, in a sense, like be following the only path that they could, because S3 has that particular peccadillo, right?
Gotcha. And you said SQS as well.
I think
Might-
SQS, SNS, KMS.
Okay, yep, so those are
OpsWorks. Yeah.
all ones that we used. So maybe, yeah, I just had the experience with the exceptions.
Yeah. Yeah, it's unfortunate. Well, and the exceptions are really popular services. So
Yeah.
what's happened over time is that Amazon has retired resource-based policies for other services. So you'll see eventually, if they really want to, they'll get to it where they actually will retire those policies. So S3 is hard because everyone uses it. All right. Okay. Just know that Access Advisor, which is inside your account, will tell you, by the way, who accessed and did what. So if Access Analyzer, right? But Access Advisor is usually the last tab. It'll show, like, for example, we're inside a user. It'll actually go through and say, hey, what did this person last access? So you can actually historically, and this, by the way, will show up in CloudTrail as well. You can historically see what someone has touched, like with my demo account. I guess I touched a lot of stuff. That's surprising. Okay. There is also, by the way, in addition to Access Advisor, there's an Access Analyzer. That's actually a section inside of IAM. What it does is it basically helps you analyze like which resource-based policies are sharing out with other entities. So in other words, it'll tell you who you're sharing S3 and SQS and all that with from an account perspective. Like, I don't think I'm sharing anything out, but I was sharing Cognito. Let's go take a look. Yeah. Oh, that's right. I had a Datadog integration that I was working on. That was just a few days ago. So just know, like, for example, I have a bucket policy, which is like a resource-based policy that basically says anybody can access this like particular like bucket. I think I had a Cognito do not delete. Ouch. Okay. I wonder if I deleted that. Anyway, regardless, when you've shared something out with a third-party provider, even if it's another account or if it's AWS or Datadog or like whoever you're federating with, it'll say, hey, by the way, we granted these people write access, or they got read access. It'll show the federated user or the account that we granted access to, right? There's some archives with Cognito. I don't think I resolved anything. Oh, I did. Hi. Oh yeah, I did resolve that because it kept throwing an error every time it saw me elevating my role. So I actually like tagged that and said, hey, stop reporting that as a problem. That's me. Okay. So Access Analyzer is different from Access Advisor. Advisor is a per principal service. Access Analyzer is a per account service. Okay. Other things is that when you grant someone permissions and it buttresses up against policy boundaries, the policy boundaries always win. So even if someone has said, hey, by the way, you can access ground station, satellite ground station to do whatever you need to do, if there's a permission boundary that says you can't do that, then you won't get access. So to put this in visuals, Here, someone is trying to execute a request, but it hits the permission boundary and it doesn't make it. Whereas the one on the top is actually gone through the SCP filter, gone through the permissions boundary filter, and is actually able to make it right into whatever they're targeting. So just know that SCPs are evaluated first, then permission boundaries, and then any of your kind of identity-based policies or resource-based policies, actually. Permission boundaries, I've only ever seen exist for identity-based policies. I don't think you can do I don't think you can do permission boundaries for resource-based policies. But the real answer is I don't know. I'm speculating because I don't know that I've ever done it. I've only ever used resource-based policies straight up. I don't think there's even an option for permission boundaries. Anyway, this definitely works for identity-based policies. For resource-based policies, SCPs will work, but I don't think permission boundaries work with resource-based policies. Okay, so that's just the security policy story. Now we're going to talk about just briefly about federation, and then we're going to talk about managing multiple accounts. So for example, someone will say, hey, I've got a ton of Active Directory accounts for my team. How can I simplify authentication for my team? Well, part of that is that let's just set up an identity provider. So whether it's any of the third-party providers, you can actually hook, as long as it speaks SAML 2.0 or the OIDC protocol, like the OpenID Connect, you can actually federate your identity, your IDP, your identity provider with AWS. I mean, it could be Apple, Active Directory, it could be Open LDAP, right? You could use any kind of, as long as it's an identity provider that actually will speak those two protocols, you're good to go. Now, since Active Directory groups are not related to AWS permissions, users are like required to authenticate 3 times. So in this particular case, you've got AWS, you've got Active Directory, you got external services, and so they got to federate. So how do you get to single sign-on? Well, AWS has a service called single sign-on that basically maps user permissions across all your accounts. So you can use SAML 2.0 to assert this. It actually has a user portal as well that you can use to find your AWS accounts and your cloud applications and everything in one place. But single sign-on will allow you to aggregate all of your SAML 2.0 aware applications into a single entity. So it acts like a portal, if you will. Notice it supports Salesforce, Box, Office 365, and a bunch of others. So it will integrate with a lot of industry standard SSOs. Okay, that's federation. Now, one thing to mention is, remember, federation is that when you authenticate with Active Directory, you do need to figure out what role those users in Active Directory or groups are going to take over in AWS. So there still has to be some assignment there. Last question was, how do we keep our accounts compliant when we're running at scale? So organizations, which by the way, can be massaged into control tower, this is a way to do it, right? So by the way, there are great white papers on multi-account strategy, but basically it's like, how do we consolidate billing and get economies of scale? How do we isolate accounts from each other that shouldn't be able to talk to each other? How do we isolate accounts from processes and services they shouldn't have access to? How do we enforce security and compliance? How do we like do our security posture as an enterprise? Organizations was designed for this. I actually think I turned on organizations last year. Let's see. Should still be rolling. Oh yeah, here it is. So notice that I have a root account, which is my management account. Oh, it wasn't last year, was it? Oh no, that was just last month. Jeez, must have been thinking about another account. Here's my primary account, and then here's another like student account. Now notice that this is just a variation on my standard email address. Because by the way, if you use Yahoo or whatever, if you put a plus sign after your username, it's going to let you do that, but it's just going to ignore it. It's still going to deliver it to your account, but it looks like a distinct username. So if you're using Yahoo or MSN, Outlook or Live or any of that, or Gmail, I know. I don't keep track of these things. And Proton Mail does the same thing. If you put a plus sign after your user, it's going to ignore everything after the plus sign, but it makes it distinct. So for example, if I was like, man, I really like this and I want to add an AWS account, I could call this UAT, change this to student 2, leave everything alone, right? And then what I can do is just create another account. And then what will happen is that AWS will actually create another account as part of this organization, or I could have invited somebody else into my organization. Now they have to say yes to that. So they get an invite, they say yes, and then they're part of my organization, which means they subject themselves to my control policies. They can leave, by the way, my organization at any time. So notice that already what's gonna happen is it's gonna show a UAT account that's gonna show up underneath here. And we can actually view all the pending account creations. Oh, is it already done? Let's see. Look at this, it's already done. So notice that UAT is listed there. It created yet a new account. Look at this account number, by the way, versus this account number. Is that how many accounts they've added since I opened this thing up? I'm just kidding. I have no idea. So point being is that it took me just that easy to create a compliant account inside of AWS. Now, I've kind of fooled you a little bit because this is Control Tower with organizations. So when I create a Control Tower, or also known as Landing Zone, it's got a bunch of different names. Basically what I did is I created a structured hierarchy for how I wanted to manage my accounts inside of AWS. And so, by the way, all of my billing now centralizes on this management account. So anything that the other accounts charge, it actually shows up in the billing console for my primary management account. Notice that there's a security account here as well. All of my logs, API logs, CloudWatch logs, AWS config logs, they all go to that security account. So what I've done is that if there's 500 accounts in here, I actually have access to all of the billing and security information, and I can create services control policies if I want to, right? Like service control policies against the system. Now, notice that the current policy I have is full AWS, but I could create other policies if I want to and limit access to, say, quantum computing, or I don't want them to use DynamoDB. Like, we can do that. And so this is what organizations does, is organizations allows you to cohesively manage multiple AWS accounts. Now, I can stick those accounts, as you can see here, in different organizational units. And I can apply different policies to different OUs as I see fit. Now, here's the funny thing. If I have identity-based permissions and I have SCPs and the allowances overlap, then we're allowed to go forward. If the SCP says I can't do something, that will trump identity-based permissions and I won't be able to do anything. Here's an example. Let's say I'm granting EC2 full access, but I'm restricting it to a single region, right? In this particular case, what happens is that I've made it so that none of these accounts can run any resources unless they're, for example, in US East 1, like Virginia, or US West 2. So think of SCPs as a filter by which all of your permissions flow through. Now with Control Tower, what ended up happening is I took organizations and I made it even stronger, which is what you saw me do. And what happened is that I created what's called a vending machine for accounts using Service Catalog and CloudFormation. There's a security OU, which you saw. There's a sandbox OU, which you saw. And I automatically enabled single sign-on in the AWS Active, which is basically the Active Directory service. So if we go back and look at the account, you'll notice assuming I can get back there. Here's my sandbox, here's security, here's my management account, and then here are 2 other extra accounts that I created. So I've got the security and sandbox accounts listed right there. So control tower is a really simple way for you to orchestrate a multi-account organization easily. So it's a great product for that. So just keep that in mind. If you ever need to start from scratch with an enterprise or a startup, use control tower or landing zone, either one. They're about the same thing. Okay. Let's do a little knowledge check. And then I know it's the post-lunch coma. So, but we're gonna keep on rolling forward. Which of the following can be attached to a user, group, or a role? Give me an A, B, C, or D. Someone tell me. Which of these can be attached to a user, a group, or a role?
Identity-based policy. Oh,
That's-
sorry.
No, it's all good. That's right. So identity-based policies, right? Those are the ones you attach to a user's, groups, or roles. Which policy type is not assigned to security principles and can grant permissions to access a specific resource? I also said there were only a few services who use this. I think they really like D for some reason. Gotcha. Okay. Resource-based policies, sorry. Resource-based policies were the answer. Which of the following are benefits to using roles? Let's select two of these. What did I say roles were really good for? Excuse me. B and D. That's right. A doesn't really apply. C, definitely not permanent access with roles. And then E negates the need for users. Well, if that was the case, we wouldn't be using users, but we still need them actually. So the answer is B and D. All right. Here's a silly question. Root users should not be used for daily administration of AWS account. Is that true? What should we be using for daily administration? It's true. Shouldn't be using for daily administration of our AWS account. That's dead on. Ideally, you would use an IAM user. Good. Okay. What service can simplify your login process for Active Directory, AWS account, and various third-party services like Salesforce, Box? Good, yeah, single sign-on. That's it. Okay, does anyone have any questions for me about anything that we just covered or talked about? Okay. All righty then. All righty then. That's the end of module 2, but it is just the beginning of our journey together. Let's see, we're not going to talk about containers. What's the next thing we're talking about? We're going to talk about networking. But before we get into networking, I feel like we should take a break. I know you want to relentlessly keep going because you're all type A students who are very intently learning, but we're going to take a short break. So let's say it's 2:07 right now. Come back at 2:27. So in 10 minutes, take a 10-minute break. And I promise you get a longer break later, but we're just going to take a short break now. So come back in 10 minutes, okay? Put a timer up.
Hey, Michael, this is Jasmine. I forgot to click on End Lab before lunch. So all the stuff I did in the morning are gone. Should I recreate them before one next lab?
No, that's what's supposed to happen. Everything is supposed to be deleted.
Oh, okay, great.
The labs are all independent, so you'll actually be focusing on another lab in another account.
Okay, thanks.
Yeah. Okay. So moving on to networking. Does anyone have any questions about how to deal with security around AWS in terms of users, groups, roles? Anything anyone wants to ask? Okay. So let's talk about it. First of all, which percentage of your workloads are publicly accessible? Someone know the answer to that? In general, for travelers, which percentage of your workloads are publicly accessible? I really don't have any idea. I think that most of your workloads are actually pretty private. Don't get me wrong, I'm sure you have a website and other APIs or whatever, but I don't know that Travelers publishes a lot of public consumptive stuff, but you know, who knows? I think the real answer is we don't know. Okay, so here we are. We're going to talk about with our little stakeholder feedback. So first, everything in network engineering starts with security, which I think that's probably pretty consistent for enterprise. I don't know about the statement that we love packets, watching packets flow. I feel like that may not be true for everybody. I don't know that everybody loves watching packets flow across the wire, but regardless, I'm sure isolating and controlling routing and stuff like that, building highly available networks, I'm sure that's all true. Support for IPv6, I'm sure is also true because, you know, we've run out of addresses. So how do we configure networking to meet these stakeholder needs? Basically, security, high availability, latest features around IPv6 and filtering access. So, I mean, the real question that we have is how do we build dynamic and secure network infrastructure? How do we divide your AWS account into like different segmented, filtered subnets and networks? And how can you monitor and direct and filter traffic that is moving in and out of a network? So we're basically going to talk about basic IP addressing concepts, IPv4 and IPv6 in different facets of like how to create a virtual private cloud inside of AWS. This part corresponds to this one thing that we were talking about earlier, particularly VPCs, public subnets. These are private subnets, so we'll get to them eventually. NAT gateways, internet gateways. They're missing something called routing tables on here as well. But these are the components we're going to talk about is basically core networking. So the solutions that we have for those issues, for one, is segmenting, creating networks using IP addressing and subnetting. The fundamentals of how virtual private clouds, which is basically a networking construct, work inside of AWS. And then how do you manage traffic and security of traffic for VPCs? So for example, are we going to run out of IP addresses? So we can start planning the IP address space, right? Now, here's the funny thing. So IPv4, which is what we're mainly familiar with, are like the 10 addresses and the 192 addresses and the 172 addresses that we're all super familiar with. It was developed in the early 80s and it uses 32 bits divided into 4 decimal numbers. So you can see it listed there, and that the bits, the maximum that slash, everything after that slash can be is a 32, which means this specific host, right? But each of these numbers represents 8 bits, these decimal numbers here. So IPv4 allows for up to 4.3 billion IP addresses. And so it, you know, as you can imagine, that's not a lot actually, when you compare the like over 1 trillion devices now, what on the internet. So addresses must be reused and masked, right? So IPv6, this version here was actually developed in 1998, and it uses 128 bits for addresses. This allows, just to put this in perspective, 340 trillion addresses. So IP addresses avoid ranges that overlap with other networks to which you might connect. So numbers are grouped in 4, giving 8 groups or blocks, basically 16 octets that you can use to group things together. The groups are written with a colon as a separator. So what this means is that basically we have 340 trillion addresses that we can use for IPv6. This is just starting to be rolled out, and that you can actually subnet this out into subnetworks, if you will, for a particular range. One thing that's notable about IPv6 is that there is no private RFC range for IPv6, at least none that no one's officially declared that I know of, right? Basically, when you get an IPv6 address, you basically have an internet routable address instantly. Most of us are still dealing with IPv4, but just to know that IPv6, much like containers, is slowly starting to take over and eat everything. So. Classless internet domain routing, or CIDR for short, is a way of kind of a notation for delineating which part is for computers and which part is networks. So, you know, Amazon, by the way, VPC support at different like CIDR block sizes, right? Basically /16 to /28. So if we were to look over here, that means that you can have either 16,000, 65,000 addresses from IPv4, or you could have 16 if you use the /28. But this range between 16 and 28, you have to keep track of this because this shows up on the exam if you decide to take it. The largest network you can make is of 65,000 hosts using a /16. The smallest you can make is a 16 host network using a /28. Just note that by default, you are granted one of these IPv4 blocks to your VPC by default. You can also add an IPv6 block to your VPCs, but that doesn't happen by default. You have to say it, right? You have to tell Amazon that's what you want. Now, if it's a 10 address or a 192 address or a 172 address, it's typically considered what's known as a private IP address. Most of our home networks use private IP addresses. And if you're using a private IP address, that's not routable across the internet, meaning the internet cannot get to it, and you cannot get to the internet per se unless you have an ambassador or a proxy who will go to the internet for you. We're going to talk about those ambassadors or those proxies later, but just to give you a hint, that's what your cable modem at home does, is it becomes like a NAT gateway, which allows you to traverse the gateway in order to get to another network, like the internet, for example. Now, if you don't want your computers to be able to talk directly to the internet or have the internet talk directly to them, you can remove access to the internet and create what's called a private subnet or private IP address. These IP addresses are not routable to the internet, and they can be networks as well as just an IP address. A public IP address is an address that is actually routable across the internet, and so other public IP addresses can get to that public IP address. So just know is that you can have a public and private IP address, you can have a public and private network. The only difference is that can it get directly to the internet or can the internet directly get to it? Just so you know, there's firewalls involved, so it's not like you're going to get hacked, but being able to talk directly to the internet or avoid it, important distinctions. Any questions about that thus far? About the networking? Okay. Let's then move up past IP addressing. By the way, the RFC for IPv4 that does the 10 addresses versus the 172s versus the 192s, that's a RFC 1918. That's a document that says these IP addresses are actually reserved for private use, which is what most of us use them on our home networks because that's what they're designed for. Now, that's just generic IPv4 networking. How do we limit internet access, provide high bandwidth for instances? How do we create a secure internal network for our AWS usage? Well, this is where all those components that I was talking about before that were on that diagram, this is where that all comes into play. So the first thing you do is you actually create what's called a VPC or virtual private cloud. Now with the virtual private cloud, you can actually launch resources into virtual networks. Now VPCs will span an entire region, but in order to use that VPC pie, you have to cut it into smaller slices called subnets. Subnets sit in a data center, so an availability zone, and subnets cannot span more than one availability zone. They have to stay in a single availability zone. So in this particular case, this VPC sits across the entire region. And if this was Oregon, you could create 4 subnets, one in each availability zone, and those subnets would be locally isolated to that AZ. So in this particular case, if we were to evolve this picture, here are public and private subnets that are now set up in a data center, namely an availability zone inside of a region. Now notice that the IP addresses that are used for all of these networks, they cannot overlap. So it couldn't be 10.1.0.0/16. It couldn't be they couldn't all have the same number. They have to have different numbers because that's how networks work, is they have to have different numbers in order to not like step on each other's toes. To further refine that, let's say we created a VPC with a CIDR of /22, which means that it has 1,024 total host IP addresses or computers or devices it could run onto it, right? Be aware that Amazon, you're going to lose 5 IP addresses off of that block because Amazon's got to take a few for networking management and a few for DHCP and DNS and some other things. So just know that Amazon reserves these addresses for their own use to keep your AWS account secure and running. Other things to know is that when you create a VPC with 1,024 IP addresses, you then break them into subnets. The subnets further define the IP addresses that you have access to. So in this case, they are creating a pie of a quarter. So 251 addresses. It's pretty good. Here's another slice of the pie with 251 addresses. Here's another slice. Here's another slice. You can, by the way, assign an IPv6 CIDR block if you want. Just remember that when you create a subnet, sorry, not a VPC, but just a subnet in particular, you're going to lose 5 IP addresses per subnet. Amazon needs to use those for administrative purposes. That's just the way it is. Now, in order for these subnets to get connected to the internet, they have to traverse what's known as an internet gateway. If the firewall allows it, by the way, that means a customer can traverse the gateway and get, for example, to an EC2 instance. And while these guys could talk to each other, these guys cannot talk to each other. So a private subnet EC2 instance doesn't get to go to the internet, right? A private subnet EC2 instance can talk to this instance, but it can't go directly to the internet. Notice that it has a 172 address. And so even though this guy has a 172 address, it also has a public IP address. And that's how it's talking to the internet gateway. But this guy doesn't have that, so it can't do it. So just know if it's a private subnet, it does not have direct access to the internet. Now, this private subnet is using this private route table right here. This public subnet is using this public route table. Notice that any traffic that it doesn't know where it's supposed to be goes to this internet gateway ID, which is right here. So all traffic by default is sent to this gateway if it's not local traffic. Otherwise, if it's local traffic, I want you to note that it actually like looks locally for that information. Every VPC, by the way, and subsequently every subnet has a routing table that says, this is how you get to stuff. This is how you find stuff. Everyone, right? If you don't give a subnet a routing table, it's going to use the one, like the main one, the VPC's route table. Route tables are maps that say, hey, are you looking for this network? Go over here. Are you looking for the internet? Go over here. Route tables are a great way to control security because you can literally remove the existence of other networks from a network. It's kind of fun and cool and weird and complicated. It can get complicated. Have I mentioned that it can get complicated? It can get complicated. Other things to note with a public subnet, notice that the routing table again points to the internet gateway. That means they can go over here and then get to the customer. Notice also that IPv6 can show up here as well, that specifying a local network. Just know that the private IP address of an instance doesn't change unless the instance is terminated. And traffic that is inside the subnets of a VPC just stays within those subnets. It doesn't shift around or anything. Now, when you create your Amazon account, Amazon creates VPCs by default for you. They span many, they are inside of many availability zones inside of a region. They launch AWS resources immediately. Just be mindful because you probably want to create your own VPCs when you are launching your account instead of using the defaults. Using the defaults gets really complicated really fast. Okay. Notice, let's see, what's changed here? Oh, notice that they added a default gateway to this private gateway down here. So they added this entry right here. And that changes, by the way, this private subnet into a public subnet because now it can talk to the internet gateway. If we remove this entry to make it so that they can't see the internet gateway, both of these public subnets would then become private. So here, for example, you might ask yourself, okay, Michael, how do I manage multiple product teams? Do I give them their own account or do I give them their own VPC? Most organizations will give you your own account because then that way they don't run into account limits. Some organizations will give you your own VPC, which is not as scalable. Multi-account is usually the way to go, which is why we even looked at organizations in the last chapter. So that being said, if you need to make an instance publicly accessible within a VPC, you have to assign a public IP address. Now, most of the time that's done for us, right? You also, by the way, need to make sure there's an internet gateway attached to the VPC, which is typically there unless somebody's messed with it, and then update the public routing table. So these sections right here. When this one boots, by the way, in order for it to get out to the internet, we have to give it a public IP address, which it then grabs and it uses that to run the information down. Okay. So in addition to creating VPCs, which have subnets inside of them, the subnets each can have routing tables that allows them to route to things like internet gateways or to NAT gateways to get to the internet. In addition, you can actually create elastic IP addresses that can be statically and persistently assigned to EC2 instances. What this means is that unlike having a public IP address, which can rotate around, an elastic IP address is a public IP address that's assigned to an EC2 virtual machine that does not come off that virtual machine unless you terminate it. And even then you could recreate the IP address and just pull it in, right? So an elastic IP address is a static public IPv4 address that can be used when you want to make sure that someone is accessing a resource with a consistent IP address. Notice in this particular case, what they did is they took the IP address off of this instance and they moved it over here. And even though the private IP addresses are different, they're now accessing a new instance using that same IP address. You can, by the way, bring your own public IP addresses. It just requires some significant configuration to pull off. Questions of any type? Okay. Let's see. NAT is that way of getting a private subnet to talk to the internet, but the internet can't see it. So this is interesting because what this is this EC2 instance, according to the route table, is going to go talk to this NAT gateway and going to go out to the internet. And when it responds, it's going to come back in. But here's the cool thing. The internet cannot initiate traffic into the subnet. What happens instead is it gets a response that says, hey, by the way, no TV here. There's nobody here. So this prevents the internet from getting to the system, but the system can still get outbound to get its patches and software and other things. Now, the NAT gateway is a service that you can initiate. Do note that Amazon will allow you to roll your own EC2 instance as a NAT gateway. That's how we used to do it in the old days. Just know that that requires a lot more configuration, but you get a lot more control as a result. Here's a NAT gateway where you've added a NAT gateway to the routing table. So instead of using an internet gateway to route, you're now using a NAT gateway to route. And so this EC2 instance goes to here. Actually, let me shift that. Goes here, talks here, gets to the customer. Notice that this is outbound only. This is not inbound traffic. Outbound only, okay? Notice that this NAT gateway has to sit on a public subnet to function. So if you haven't noted that, please note that a NAT gateway, in order to be an ambassador for a private subnet, has to sit on a public subnet. If a device is not on the public subnet, it cannot get to the internet. So in order for a private subnet to route through a NAT gateway, that NAT gateway needs to sit on a public subnet. All right. So this is how you connect private subnets to the internet. Now we're back to this drawing that we were looking at before, and notice that you probably have an idea of what the components are. You now know what a public subnet is, and these are listed as private, but we didn't call them private. You now know what a VPC is. Here's the internet gateway, right? Routing tables are not listed here, but they're here. And we haven't talked about ELBs yet, but we will. Now, what you stick inside of your subnets is called an elastic network interface. Every time you launch an EC2 instance, it has a network interface attached to it. That interface sits inside of the subnet. Every time you put a network card on a subnet, it automatically gets a firewall called a security group. That security group wraps around the network interface and says what is allowed inbound and outbound to the interface. It is a like stateful firewall. Now, the thing that's a little weird, just so you know, is that adding a network interface to an EC2 instance does not make that EC2 instance faster. It just gives you a categorization. Like it just gives you a way to route traffic. It doesn't actually make it faster. EC2 instances are pinned to the speed network-wise that you buy. So just know that adding more network cards doesn't make an EC2 instance faster. One network card is just as fast as 10 in Amazon land. Now, here's a cool thing about using VPCs in this function is that if you want to add IPv6 networking to your IPv4 VPC, you can do that easily by adding what's called an egress-only internet gateway. This allows you, by the way, it's a service that allows you to connect from IPv6 to your instances, but it does prevent the internet from initiating a connection. So you don't need a NAT instance for IPv6. You can actually use outbound in egress-only internet gateways. But just note that they're only for IPv6. If you want IPv4, you got to use the NAT gateway. Okay. Questions about NAT gateways, internet, any kind of egress gateways, any of these gateways that we've talked about. Private and public subnets, NATing, elastic IP addresses. Most of you are like, I already knew this, Michael. This is rehash for me. Okay. All right, last but not least, and then we'll take another short break. Well, we'll take a longer break actually, is VPC traffic security. So we've already talked about IP addressing, either IPv4 or IPv6. We've already talked a little bit about VPC fundamentals in terms of private and public subnets. How do we route out to the internet? How do we but we haven't talked about how to take inbound connections, which is something we'll talk about in module 2. But it's like, how do we get out to the internet, right? And how do we secure this traffic? Well, this is where things get, this is defense in depth. This is where things get really interesting. So let's say someone is coming in and they're trying to get to this instance, but they're coming across the internet gateway. The first thing that has to happen is first, is there a route that sends you to the proper network? Yes. Does the firewall, this guy right here, allow you to get to the subnet in question? Yes? Okay, keep going. Does the firewall allow you to get access to this instance? Yes? Okay, you can talk to it. So just note that here and here, there are 2 firewalls to get access to an EC2 instance. 2 firewalls, two firewalls. One is attached to the network. The other is attached to the NIC. So just remember that. That assumes, by the way, that there is even a map, a routing table to get to all these spaces. So remember, stateless firewall here, stateful firewall here. All right then. Now, network ACLs are stateless firewalls. This is what you use when you define a rule that says, hey, this person can get into this web server on port 443. That's exactly what this is designed for. Hold on just 1 second. My feet have gotten really cold. I'll be right back. I had to go get my Godzilla slippers. Just kidding. They're just Berkeys. All right, network ACLs, stateless firewalls. Remember, they wrap around a subnet. So you can see here, they're just wrapping around the subnet itself. They're not wrapped around the instance, not like this. They're wrapped around the subnet. Okay. Now to keep going. Security groups, by contrast, are wrapped around the network cards attached to EC2 instances. This uses stateful rules. So whereas network access control lists require 2 rules to allow traffic to initiate and respond, security groups, since they're stateful, only need 1 rule to initiate and respond. So 2 rules for stateful network access control lists, 2 rules for stateless access control lists, 1 rule for stateful security groups. Now, by default, all traffic, inbound traffic into an EC2 instance is blocked by default. All outbound traffic is allowed, but inbound from the internet is very limited. If you want to change that, you can. But by default, stuff can go out, but stuff can't get in. Now you can create your own custom security group rules, for example, by limiting it or delineating it by everything from port to protocol to source. You can even do destination, right? Protocol, port, right? Comments. You can add the security groups of other, like you can add the ID of other security groups in there. This becomes important because you might want to chain security groups together so that the web servers are the only ones who can talk to the app servers. The app servers are the only ones who can talk to the database. You can literally chain security groups together so that people can only talk to other people if they're actually a member of that security group. So the security groups are firewalls to prevent a subnet-wide breach. Network access control lists are there to prevent a VPC-wide breach. So again, defense in depth is the name of the game. Security groups, network ACLs, and route tables all work together to create multiple layers of defense. That's the whole intention. If you want to see a comparison of these things side by side, let's take a minute and look at this. So 1, security groups are attached to a network interface. Network ACLs are subnets. Security groups will only allow traffic. They will not deny traffic. So if you want to deny an IP address, you have to use a network ACL, a subnet firewall. Security groups are stateless. Network ACLs, I'm sorry, security groups are stateful. Network ACLs are stateless. So network ACLs, by the way, in your account allow communication by default. Security groups by default block all inbound communication from the internet. So keep that in mind, is that your account is locked down by default. You have to like put a hole in it in order to allow stuff to get access. Okay. Good. Okay, let's do a little knowledge check. 1, a single Amazon VPC can span multiple regions. Is that true or false? Yeah, that's false. VPCs are region specific. Good. Okay, what do you have to do in order to make a subnet public? What device do you need to connect a subnet to? Good. Yeah, you have to route all outbound traffic to the internet gateway if you want to get this to function. In other words, if you want to make a subnet public, it has to by default send its unknown traffic to the internet gateway, which will then connect it to the internet. Good. What function does the NAC gateway serve? Is it a load balancer? Does it allow internet traffic initiated by private subnets? Does it allow instances to communicate across subnets? Or does it increase security in any way, shape, or form? Yeah, so it allows internet traffic initiated by private subnets. That's accurate. Okay, what should you use to create traffic filtering rules for a subnet? In other words, which of these is a firewall that attaches itself to a subnet? Good. So to create traffic filtering rules for a subnet, you actually need to use the network access control list. So this is actually going to filter traffic, whereas a route table only directs traffic. Good. All right, which ports are open by default when you create a new security group? Which two of these are true? Good. So nothing is allowed inbound and anything is allowed outbound. This is true by default for security groups, is that this is like the default way this happens. So by default, everything is restricted from inbound access, but anything is allowed outbound. Good. Good responses. Thank you. This is the end of module 3. So technically it's 2:55 and we've got 2 hours to cover a module and do a lab. Does anyone have any questions for me whatsoever at this point?
So this might be a networking question. I know you very quickly skimmed it when you took a VPC and you sliced it into 4 pieces. I'm just wondering how one would decide, you know, how many pieces to cut it into and how basically you subnet that CIDR that you had at the, yeah.
Well, the question is how many computers are you going to run inside that network? For example, since if you were going to run across 3 subnets and your product for redundancy purposes requires 20 computers across all 3 subnets for a total of 30, then you'd have to pick a subnet division that actually could handle, let's say, 30 IP addresses. Why 30? Just for redundancy's sake, because you don't know what kind of growth you're going to have, right? But what you do is you subnet it based on the maximum number of computers you expect to have on a single network. So like, for example, most of the 192 addresses will support up to 255 devices, which should be pretty simple. Unless you start running a bunch of Raspberry Pis and some IoT devices, and the next thing you know, something's getting eaten, which I'm not going to admit to anything, but that might have happened before to me, right? So that's really the way you determine it, is that you do a little bit of planning and figure out how many computers you're going to stick on there.
Okay, because a lot of the times I see, the instructors very quickly saying, okay, well, this subnet's going to have 10.0.1 point whatever, right? I was like, where did you get that one? Where did you get that? Like it seems right. I know it's not random, right?
Right.
But like, it's like, how did you pick that number? Right? Like, how does this subnet have a 0.5 or 0.3 or you know what I mean? It's kind of glossed over.
Yeah, it's unfortunate because it's kind of a prerequisite, but honestly, we all forget it because we don't use it, right? Not most of us are not network engineers, so like there isn't a big discussion about it. The reason is that if we go back to this number, because and it's a valid question, right? If we go back to these numbers, these octets, these number ranges, and let me be very specific here. These guys can range from 0 to 255. So we're choosing 10s because there's this thing called RFC 1918 that when we are doing it private IP addresses, we have to pick from a certain set of numbers. So let me pull this up actually. Yeah. So RFC 1918 basically says that when you use IP4 addresses, here are the IP addresses that you're allowed to use. So it can be 10, and this can be 0 to 255. This can be 0 to 255. So you can see it over here, right? I can basically choose any number between 0 and 255 for that 10 address if I want to. Same with the 172.16s to the 172.31s. Same for the 192.68s. I can choose anything between 0 and 255 for these addresses. Okay, so you're like, okay, great, Michael. Awesome. I'm so glad that we now know that we have a range, but why would you choose one number over another? Right?
Exactly. Yeah.
Yeah. And so the catch here is in this subnetting here. So what happens is that if I say that I want this to be a /16, what this means is that whatever I've chosen for these two numbers cannot change. In other words, if this was my VPC, that VPC would always start with 10.22. And then when I created my subnets, I'd have to slice them off of this number. And that would only leave this number available for hosts if I was doing like clean subnetting.
Okay, so what would that first 0 be? What would it be a 1? Because
It could be a 1, could be a 2, could be a 3. I have 0 to 255 to choose from. So I can pick any number I want to as long as it's between 0 and 255.
Okay, so there is no rule to say, this should be a 1. It should be like it has to go in order. I can basically say I want it 251 as long as it's unique. You're good.
You're good. That's it. Uniqueness is the only thing you need. The other thing though to remember is that when you subnet these out, they have a certain size associated with them. So that's what this is telling you, is that you're going to get a certain number of hosts. But I got to tell you, 4,000 hosts on a single network is a lot. So most of us don't necessarily need these numbers. But as long as this number is unique and this, sorry, not that number. Whoops. Let me erase that because that's not what I meant. As long as this particular number is unique and this number is unique and this number is unique, for subnetting purposes, we're probably fine if it's a /16.
Okay.
Yeah. And just to say this also is that there are.
Yeah, it's just that every time subnets are created in these courses, it's like, where is that number? Why did you choose 3? Okay.
And so they have these things called subnetting calculators, which most of us use. And so what they'll do is they'll ask you questions like, okay, how many hosts do you need? Let me find a better one. So for example, let's say I need 30 hosts per subnet. What will happen is that this calculator will actually tell me, what do I need to set my subnet mask to, which is what this number is right here. This is my subnet mask, the /32/24/16. They will tell you what you need to set your subnet mask to if you want to get 30 hosts per network. If I need 254 hosts per network, notice it says /24. If we go look at this, notice that this /24, that's the third one down, that will actually give me 251 hosts basically, which is what this is saying, 254, 251 hosts, right?
Will want 30 and some will have 1,000, right?
Right, exactly. In other words, if I change the mask bits, let's say I want to go past this. let's say I want to do a class B. Actually, you know what? Let's do class A because we were doing 10s before. If I'm like, look, I only want to use 16, that's the 65,000 hosts. See how this 65,000 hosts per subnet? Over here, it says 65,000 hosts on the lower right-hand side. This subnet will allow you to figure out how many hosts you need. And so this is what the IPv4 networking is for, is it helps you divide that number into which part of this is a VPC network, which part of this is the subnet network, and which part of this is the hosts. So that's what all those numbers translate into, is how to segment these kind of things out. But there's subnet calculators like this that'll easily help you figure it out without having to do a lot of math.
Okay. Right.
Yeah.
Thank you.
It's a big subject. We could spend a long time on it. It's a good question also. Good. Other questions? I didn't mean to get out of that. Okay. So currently it is 3:03. And so what we're going to do is we're going to take a 20-minute break. So let's say it's 3:04 because it hasn't rolled over yet. So come back at 3:24, take a 20-minute break, hopefully get away from a computer. And at 3:24, I'll put a timer up. We'll come back and we'll finish out this last module on compute. And then we'll roll into a lab and you will create your own VPC and you will launch some EC2 instances. Okay. So we'll make all this real in just a second. All right. I'll put a timer up. I'll see you in 20 minutes. All right. We're back. Okay. So it's 3:30. We got about an hour and a half together, give or take. We're going to cover a little bit of compute and then do a lab. That's going to be the end of our day. My question for you is that, does anybody have any questions about, permissions management, anything about networking, anything about fundamentally accessing AWS? Any questions thus far? Let's see. No? Okay. I'm going to pre-warm the next lab. Wow. Okay. So here we are. We've actually finished fundamentals, account security, networking. Now we're on compute, and this is going to be the last subject we cover today. Tomorrow we'll continue with storage, database services, monitoring, and automation and containers. Just a reminder that on the last day at the very end, I will talk about certification in detail, talk about a step-by-step plan you can use to study for certification. So I won't leave you hanging for those of you who are looking for certification. I'll make sure you have some resources to do it, okay? Okay. All right. So compute is an interesting topic because, well, actually, first one. So, by the way, this is a great question for everybody. How many of you have ever used EC2 instances or Lambda before in your role? Okay, good. So it seems like most of you have used EC2 in some form or fashion, or Lambda. So good. So now we're going to talk about compute. And remember, I said there were 3 ways to really host an application in broad strokes: virtual machines, containers, and serverless. We're going to talk about the easiest, the most abstracted and the most manual way, which is virtual machines and Lambda. We'll talk about containers, I think, on the 3rd day, if I remember correctly. Might be the end of tomorrow. So here's the deal. So we're in our fictional company. You're the cloud architect. And so our computing needs are moving fast in a bunch of different directions. So you want to be able to meet a wide range of requirements, right? But they also want flexibility, and they want to be cost effective, which is common requirements, really. So what we're looking for here is that, we want to understand which services are available. If we use EC2, what are AMIs for? How do I find the best EC2 instance type? And how do I optimize costs? And what is serverless, and what can I actually use it for? That's really what we're talking about. Now, this part of the architecture in particular is going to focus on the sections around serverless, which is what this is. This is Lambda, serverless, and about running EC2 instances raw, meaning they're not being managed by anything else. You're just running them. And then also, we'll get to auto scaling later, but it's really these app servers that we're interested in. Okay. All right. Now, with that in mind, let's talk first about compute services. So we've tested Amazon virtual machines, but there's a managed solutions to meet different requirements. So what we're looking for is that, are there different ways for us to implement virtual machines? The answer to that is, oh my gosh, yes. It's ridiculous. You can use run EC2. You can run EC2 Elastic. You can run serverless if you want to. You can run containers using either ECS or EKS, which is the Elastic Kubernetes service. You can run both of those services with no EC2 virtual machines underneath them that you manage. That's called Fargate. You can get a wizard for EC2 called Beanstalk. You can get EC2 in your data center on hardware. That's called Outposts. So we're really just going to focus about these pieces. But just know there are a crazy number of virtual machine EC2 compute options available to you. Okay, a lot. Now, 2006, I think in the end, actually, if I remember correctly, Amazon released EC2. And then in 2014, they released the Elastic Container Service because they saw containers were on the rise, which was interesting. Lambda came out around the same time. In 2018, that's when they released the Elastic Kubernetes Service. And then they started realizing specialized processors, like they designed their own processors in 2020, which was interesting and weird, frankly. So here's how this works. If you want the least amount of operating system management overhead, then your best friend is going to be Lambda. This guy right here. If you want containers and you don't want to manage the underlying operating system, then Fargate's going to be your friend. If you want containers and you don't mind a little bit of management of EC2, then ECS and EKS are going to be your friends. If you're like, I'm not going to use any of those services, just give me an operating system, this is the one that requires the most effort, but you have the most control. So control, you can inverse these as far as like, this is the least amount of control, so least amount of effort. This is the most amount of control and flexibility, most amount of effort. So note that over here, you only manage application code for Lambda. But down here, notice that you have to do scaling, provisioning, packaging, network configuration, security updates. That's all you. So AWS manages a lot up here, but not a whole lot down here. So just keep that in mind. Now, how do you know which EC2 instance type to use if you're going to use virtual machines? Well, one, just know that every AWS data center has what they call hypervisors in them that allow you to create virtual machines. This has been around for 15 years. Hell, if we include VMware, this has been around since 2001. So this is a 20-year-old technology running virtual machines at this point in time. Now, in order for those virtual machines to launch, you have to boot them. Now, you just ran a lab, like lab 1, before lunch, and you saw that you got to choose your operating system. That operating system boot image is called an AMI. It's an Amazon machine image, and it's a snapshot of a bootable disk. Linux, Windows, and Mac are the primary 3 flavors that Amazon supports. You can run other operating systems, but Amazon won't support them. But just know that this AMI is what's used to boot and create multiple copies of virtual machines. This AMI is like your bootable Windows disk. It's your bootable Linux disk. It's your bootable Mac OS disk. Now, an AMI can include a whole lot more, like permissions, other attached disks. You have to, every time you launch an EC2 instance, you have to source off of a particular AMI. AMIs, by the way, can be programmatically created using like a tool like Packer, or they have their own EC2 image builder service that you can use to build your own AMIs. But I got to tell you, it's not nearly as robust as Packer. So if you're looking for a tool, please just use Packer. The builder service needs some work before it really is up for prime time, at least in my opinion. Now, when you get an AMI, there's a couple of options. So let's go to the console for a second, because I just want to make sure that you can see this. Is that if we go to EC2, and you're like, I really want to launch an image, right? So we go to launch. We're in Ohio. Notice that it gives you your options around Mac OS, RHEL, SUSE, Ubuntu Server, Windows 2019 base. These are all quick start, what they call quick start AMIs. These are Amazon machine images that Amazon built that will launch you into your favorite operating system. If you have created any AMIs, they'll show up here. I used to have one. I wonder what happened to it. Huh, maybe it's in another region. And then if you don't want to use that, but you want to use an official marketplace from an approved vendor, because you want to launch OpenVPN, be very careful, because there are typically hidden costs, like licensing costs, inside of these marketplace AMIs that will show up on your bill. They're not going to charge you directly. And then there's community AMIs, which I can just tell you right now, please do not use community AMIs. Your enterprise isn't going to let you do this anyway, because you don't know who wrote these AMIs or what they stuck in them. And detecting a rootkit inside of an operating system is a nigh impossible task. It's really hard. Can be, at least. It's not impossible. So in general, stick with Quick Start, or like most enterprises, you're going to make your own AMIs, usually based off of somebody else's AMIs. Or you might go to the marketplace and say, you know what? I really love, I don't know, Oracle. And there's Oracle Enterprise Linux. Ugh. Anyway, moving on. Oracle 8, there's a database if you want. Like, you can find the vendor software that you want. You're like, hey, I really love TIBCO, because I want a messaging bus or analytics or whatever. You can grab that here. Or if you're like, hey, you know what? I need to launch a checkpoint firewall. There it is. So just know that in the marketplace, you can find stuff. This is vendor approved. Do not use community AMIs unless you absolutely have to. In general, you will write your own, or you'll use the standard, like standard AMIs. You can just. Now, one thing to note is that Amazon Linux 2 is a hybrid. It's a clone of RHEL, which is Red Hat Enterprise Linux. Just know also is that if you choose a licensed operating system, which is like RHEL, SUSE, it's going to charge you per hour on the billing. I mean, if you start that EC2 instance and you run it for 15 seconds, you're going to pay for an hour. If you choose Ubuntu, and they now have a new partnership with Microsoft, or macOS is an exception, or Amazon Linux, they're going to do per second billing. You run for 15 seconds, you pay for 15 seconds. Just to say this, Mac is a little different because Apple hates everybody. And so you have to pay for a minimum of 6 hours the minute you start a Mac OS instance, because that's what Apple charges Amazon to do anything with their machine images. So I say Apple hates everybody. Apple doesn't hate anybody. They just want to do their own thing, right? So know that Windows is here. Here's Debian if you're really attached to that. More SUSE, older, right? Older Linux. Oh, interesting. These are pre-installed with SQL Server. Oh, yeah, that's interesting. Hold on one second. I didn't know they were doing that. So they've got SQL Server installed by default in some of these. Oh, look at that. SQL Server 2019. Cool. TensorFlow GPUs. One thing to note is that you may have noticed that it said x86 or ARM. Depending on what you choose here is going to determine which AMI you choose here is going to determine what you can choose for your machine type. If I choose ARM, by the way, and I hit select, all of a sudden I get T4Gs and C6Gs and all these different like family types of EC2 instances. And here's the question, Michael, how do I know which EC2 instances to run? Well, the cool thing about working at Travelers is, if I remember correctly, they only give you 4 or 5 types of machines to choose from. So you just look up what those sizes are and it's easy to figure out, right? But if you're like, no, Michael, like I have to choose a bunch of machine, like what do I choose, right? My favorite website for this is called ec2instances.info. Hold on. This got bought by a company called Vantage fairly recently. This, by the way, is a way for you to look at all the machines that are available inside of AWS by characteristics. So most of the time we get vendor documentation. It says something like, hey, I need a 16 gig system with 4 CPUs. Well, ec2instances.info allows you to see all of the systems that have 16 gigs of RAM and 4 CPUs just by typing it in. This website, by the way, is spectacular. Been using it for years. Obviously, it was so popular that somebody decided to buy it, right? And what this does is it allows you to figure out which machines are based on characteristics. Now, I say that characteristics, you still have to know what these machines do. Like these are ARM boxes. If you're not ready for ARM, you're not going to run ARM because it's a different processor architecture. So you may not be ready for that. But this at least allows you to identify all the boxes that could meet the characteristics. You can also, by the way, do mins and maxes and say, look, I only run machines that have a minimum of 8 CPUs. And let's say we switch it and say, you know what, I want 8 CPUs here and I want 64 gigs of RAM. You can do filters like that. Like this lists all the 64 gig 8 CPU systems. You can also do things like search against like network performance, and notice the cost listed here. So for example, one of my favorite classes of systems to mess with to do proof of concept is the T3 family of systems. Notice that these range from, that's not what I wanted, nano to micro to small to medium to large to extra large, and right, so on and so forth. So if I were, for example, to sort it this way, you can see it kind of in descending order. Notice that most of these have 2 virtual CPUs, except for the TX large and the 2X large. They have 4 and 8 respectively. These are great systems to run proof of concepts with if the boxes are large enough. If they're not, they do actually have a T4 series, but most of these boxes don't scale beyond 32 gigs of RAM. Notice the cost of one of these boxes. 16 gigs of RAM, 4 CPUs. Now there's some caveats with the T series, which most people don't know, but we're just gonna leave that alone. Oh, actually, I meant to post that out to everybody. Hold on one second. There's some caveats here, but notice that this is 33 cents an hour if you just take straight retail. You don't get a discount, you don't get in a relationship, right? 33 cents an hour. Multiply that times 720 hours a month, because 24 times 30 on average, right? Do the math. And what ends up happening is that you realize that this is a really good price for a box, because it's going to cost you somewhere about what, $8 a day for a 16. Sorry, this one in particular is a 32 gig 8 processor box, right? So the pricing on these AWS instances is actually pretty good. Now, just note that all the cloud providers are fairly competitive with each other, and Google is probably the best in terms of dollar per CPU. At least typically they are. But Amazon runs a really close second as far as price performance value ratio. Cool. All right. So this is how you figure out what machines you need based on characteristics. Amazon also wants you to know that you can choose your sizes based on what they design for, which I'm going to talk about in just a second. So I'm going to come back around to how to choose your EC2 instance. One little sidebar here is that you can create your own custom AMIs. I mentioned Packer has the HashiCorp tool that does this before. If you're not familiar with Packer, it's a fun, simple tool to use. It does have a little bit of a learning curve, but people have built tons of files for this, so you don't have to build everything yourself. You could actually just build your own AMIs using some stuff that you found on GitHub. Just make sure you read all the images that you pull in. So once you create an AMI, you can push it to Amazon, and then you can launch EC2 virtual machines based on that image. In addition, at runtime, you can actually get the image to run certain configuration commands. So you can actually get it at launch time, because you did this earlier when you launched an EC2 instance. You had a bunch of commands in the user data. Those commands, by the way, launched and installed a web server, unzipped a file after downloading it, and unzipped it in the var HTML directory, www HTML directory. So you saw this already in our first lab, that you could run commands after the machine booted and get it to configure itself. Now, Image Builder is a great way to kind of create these golden images, these AMIs that you're going to use to boot these systems. But just be aware that almost every enterprise I talk to has an already established system for how to do this. Other things to note is that the most expensive way to run a virtual machine is not where you're shared on the same hardware where other customers are. And let me be clear, just because you're on the same hardware as other customers, everybody's super isolated. Amazon runs their own proprietary version of the Zen hypervisor. It is not susceptible to the same security flaws and cracks as the other general purpose Zen hypervisor. But the other way you can do this is you can say, look, Amazon, I want my own host. I don't want my own virtual machine. I want to control my host. So you can actually get your own host. You can also say, Amazon, look, I want to run on a server that has nothing on it but my virtual machines. Typically, dedicated hosts and dedicated instances are only used if there is a security or a licensing problem. But if you want your own hardware, just to say this, there's a machine out here, by the way, that has 448 CPUs on it. You see these instances that end in metal? See how it says 6 terabyte, one metal, right? Be aware that these are boxes that you can literally install your own hypervisors into. So the 6 TB1 metal box, you know, or let's look at the 24. This is a 24 terabyte system with 448 CPUs and 100 gigabit connection to the internet. Well, I say the internet. They have a huge pipe. I don't know that it's 100 gigabits. That was speculation. Notice the pricing is unavailable. I think you have to talk to Amazon if you want to get this. It's probably like, you know, $1,000 an hour or something ridiculous. So just know you can actually get your own bare metal server. You can do what's called dedicated tenancy and just make sure that nobody else is using that hardware, or you can get a dedicated instance, which is also dedicated tenancy, but it's not an entire host. It's just a tiny little box for your instance. Now, notice that when we were going through the names of those t-shirt sizes in your lab, does anyone remember, by the way, the name of the t-shirt size of the system you chose in lab 1? What was the size of that system? Does anybody remember?
8 gig, I think.
Well, what was the code name, like the one you see on the screen?
Oh.
Because Patrick, you're probably right, but what was the code name? Good, Anastasia. It was a T2 micro. So if we go to this website, let's erase this one because we don't need that. Let's say that we search for T2 micro. Oh, this one was a 1 gig of memory, 1 virtual CPU box. Super tiny. By the way, it costs a little over a penny an hour. That's a great box to mess with, by the way. So that T, by the way, is just like this C right here. That T tells you that that box is really for testing. Now, Amazon's going to tell you it's for general purpose. I'm going to tell you it's for testing. Because if you don't know what you're doing, these boxes can hurt you, actually, which is not general purpose. You got to know how they function. The C, by the way, stands for compute. If it's an R, it stands for RAM. If it's M, it's median. It's general purpose box. If it's a, what's another one? If it's a D, it's a data warehouse box. If it's an I, it's an IO box. If it's a G, it's a GPU box. You may say, Michael, how do you know all that? Well, it's part of the exam. Or just working with Amazon, right? Notice, by the way, also that there's a t-shirt size, because when we looked before over here and we were just doing T2s, for example, notice there's nano, micro, small, blah, 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 blah. Notice that pretty much that they double each other in size. A 2X large is twice the size of an X large. An X large is typically twice the size of a large. A large is typically twice the size of a medium. You can do the math. You can figure that out, right? So the N, by the way, is an attribute. And this is where things get really ugly with Amazon. I don't know why they started doing this, but they really threw a monkey wrench in for most of us because most of us can't memorize what these attributes are. The instance family, easy. The number, that's just the generation. What version is it? The t-shirt size, the instance size, that's easy to remember. Large, extra large, 24x large, 48x large, easy. The attribute, oh man, I don't know why Amazon did that. I'm not necessarily slamming them for it, but I was like, kind of wish you'd gone a different route there. Let me show you why. AWS instance types. So if we go look at the different instance types that Amazon has, one of the things we're kind of looking for is like, well, what products do we have, right? So here's the problem is that if I'm looking for instance type details, this is where things get really weird and sticky. These T systems are definitely all test systems from my perspective. M stands for general purpose or medium, and notice they're all under general purpose. This is where things get weird though. What's the difference between an M5A, which by the way is powered by an AMD processor, versus an M5N, which uses some kind of neural network, right? And is part of the what's called the Nitro system, which is an Amazon kind of high performance system. Versus a T3A, what is an A for? Oh, well, A uses AMD. What about G? Well, G stands for Gravitron because it's now using Gravitron processors, which are ARM processors. So the problem is that Amazon added in all these letters in, and so now you got to really figure things out. But the main thing you should know is that the beginning letter and the number is the family type and the generation. So notice there's T2s here, T3s and T4s. That's 3 versions of virtual machines. Notice there's M4s, M5s, and M6s. That's 3 versions of general purpose machines. What does the I stand for? Codenamed Ice Lake. So Xeon Scalable. Okay, awesome. Again, you're going to have to look up the attributes because most of us can't keep these memorized. If you look under compute optimized, there's other numbers here. By the way, they don't necessarily mean all the same thing, although maybe they do. Oh yeah, this is actually the Ice Lake processor. And this should be an AMD processor, and this should be a Nitro system, which it is. And then we've got memory optimized systems, which are the R's. We've got GPU systems, which are the P's and the G's. I know for a fact, by the way, that Travelers uses the P systems a lot, particularly I think the P2s and the P3s. I think you also have access to a C, and you also have access to an M system. I have that in my notes somewhere, but I don't remember exactly where. So bottom line is that you have to learn what the first letter stands for because those are pretty generic. You have to remember that this is the latest generation. The attributes you're not going to memorize, and the t-shirt sizes you are not going to memorize. You're just going to know that they exist. Now, these systems were designed for different purposes. So just to emphasize what I was talking about, notice that this is all the C series. Here's the G's and the P's, right? Here's the I series, which is storage optimized, and here's the D series. Here's R for memory optimized. Here's M for general purpose or medium. Here's the T series, which I like to refer to as testing boxes because they can be used for general purpose, but they need some massaging. Also, make this distinction. Compute optimized instances have a 2-to-1 ratio between memory and processor. General purpose instances have a 4-to-1 ratio between memory and processor, and memory optimized boxes have 8-to-1. So let me ask you this. Here's a question for you. If I'm running machine learning and I want to run on a system that has, for example, GPUs inside of it, which of these family types am I going to look at? Which of these family types has GPUs attached to it? That's right. This is the series or the P series, right? Accelerated computing. Good. That's really the only one that has a confusing name. The rest make a lot of sense. If you're running a database and you need it to have a system that's heavy on memory and lighter on processor, which of these are you going to run? No. So in this case, you're going to run the memory optimized instances, right? The R series. So they are designed for different purposes, but just to be clear, with the exception of the attributes, like is it a Graviton processor, is it a Nitro system, they really just started specializing these instances here recently. So you've really got to just take a look at your workload and see what you need more of. In general, you want to use the latest generation of any of these instances. So use an R5 or an R6 over an R4. And if you need something specialized, then take a look. See what's out there. I would in general, unless you're actually developing for ARM, I would stay away from the Graviton processors. They are much cheaper and faster, but only if your stuff is set up for ARM. So pushed by Amazon, I think, to get away from Intel, but not everybody's ready for that. Newer instance types, by the way, the reason you want to use the latest generation is that they are cheaper and faster per dollar than the previous iteration. So notice that the M4 large here is slower and more expensive than the M5 large. The M6 is the same way. So keep that in mind. Now, there is a tool, by the way, that will help recommend when you are doing something with your account. So what it's going to do is that the compute optimizer is a tool that will tell you whether or not you are using your EC2 instances effectively. So it's going to watch all of your EC2 instances, and it's going to tell you if you're like, hey, by the way, this instance is like 4% utilized. Is that what you wanted? So it's not going to make any actions, but it's definitely going to generate recommendations. Now, an EC2 instance, once it boots off of an AMI, can be in a couple of different states, either pending, running, stopping or stopped, and then shutting down and terminated. Just to say, or rebooting, that's the other option. Just note that if you are using EBS, which is the hard drive service for Amazon, which is best practice, absolutely typically recommended. Some people still will not use it. They'll use local storage, which is called instant storage instead. If you use EBS backed instances, you can stop them. You can, like, in a sense, like stop them. The data's not lost. You just powered it off. If you decide to use instant storage, which is a huge no-no, not recommended, then you can't actually stop it. You can only reboot it, but it is running all the time. Okay. User data we've already seen, because you had a chance to insert something like this into your first lab. Note that this also works with PowerShell. So this can be used when the instance first boots to pass in configuration data. So be aware that that's the case. You can also, by the way, retrieve metadata from inside the operating system, right? And so, like, if you run a curl, if you run this, you can retrieve like attributes like host name, firewall, public IP address. You can retrieve all kinds of stuff. This URL right here, this 192.1.254.169.254, that is the URL to remember if you're taking any of the exams. Because that 169.254.169.254/latest/meta-data or user-data is the way in which you can curl and retrieve information inside of an operating system. So just know that this is a way in your scripts and your startup scripts to retrieve information that you can then use to apply it to configuration at boot time. Now, another thing to note, when you launch any system like a database system or a container system or an operating system in AWS, it has its own username and password database. It has its own user database. Think about this. Your Windows system has its own user database separate from AWS. Well, Amazon allows you to log into these operating systems by using this thing called the key pair. A key pair has a private key and a public key, and you hold on to the private key and you use it to unlock the public key. So whenever you log into an EC2 instance, you have to have a key pair in order to log into the operating system for the first time. If you do not choose a key pair, you cannot really log into an operating system. So I think you can go back and I think I saw someone jury rig a way to kind of retroactively add one, but it's really hard. And I think it doesn't work in all cases. So typically, if you don't have a key pair on there, it's not going to work. So key pairs are the username and passwords that you use to log into an operating system on AWS. We've been using key pairs, by the way, in non-AWS infrastructure since 2013, 2014. It's been around for a long time. Public-private key pairs are considered to be better than passwords in most cases. It is recommended, by the way, that you do tag your resources that you launch. If you don't tag them, it's really hard to track them and manage them. So it is best practice for you to tag all launched resources inside of AWS. So just note that if you're using Terraform or CloudFormation or whatever, you want to put tags inside of your automation tools. It just makes things better across the board. Okay. Last few things to really talk about is that one, when you launch EC2 instances and you do it manually, you can also create these things called launch templates. So you can use CloudFormation, but you can also create these launch templates that you can use to also launch your EC2 instances as well. So it's not like you're scoped or limited just to using CloudFormation. I will tell you that this isn't as scalable as using CloudFormation or Terraform or any of the other tools, but it is required if you're going to run an elastic auto-scaling group for your EC2 instances. Okay. Questions thus far about AMIs, the t-shirt sizes, the family types for EC2? Anybody have any questions about any of that? Okay. We're going to talk about EC2 pricing and licensing types because there's a bunch of different ways to actually optimize for pricing in EC2. Most of the time we don't have to deal with this, but it's good to know, especially if you're going to take the certification or if you have to negotiate contract stuff. Okay. There are actually 5 pricing options. That's weird. I took one of them off. There's 5 pricing options actually for EC2. So first is reserved instances, which basically says, Amazon, I want to get into a relationship with you, and in exchange for giving me a discount, I promise to pay for your resources for either a year or 3 years. So reserved instances are when something you ask for when you know you're going to run a virtual machine 24/7 for a year or 3 years. Just so you know, there's a sub flavor of reserved instances called scheduled reserved instances that allows you to say, hey, Monday through Friday from 8 to 8, I want to get a discount. Or once a month, I want a discount because I run the first Saturday of every month. That's what reserved instances are, right? Savings plans are basically, it's a bucket of dollars. And what happens is that Amazon says, look, if you give us $10,000, we'll give you $15,000 of compute. That's pretty good, actually. And the cool thing about that is that you can apply that not just to EC2 instances, but also to containers as well, if I remember correctly. Actually, they even have a bucket for SageMaker if you're doing machine learning. And then spot instances are where Amazon has extra unused capacity that nobody's using, and they'll give it to you for up to 90% discount, but only until somebody else asks for it. Then what happens is you get a 2-minute warning, and they will kill your spot instance and give it to somebody else who's paying more money for it. That is, spot instances are only good for applications that can withstand interruption, like reporting or number crunching or genomic data, right? And then the last is on-demand instances, which is how most of us pay for AWS. We actually just are like, hey, AWS, yeah, I'm gonna spin up some instances, and I'm like not in a contract with you, so I'm just gonna give them back when I'm done. Next to dedicated, on-demand instances are the most expensive way to use AWS. So just something to be mindful of is that on-demand instances are the most expensive way to use AWS. Now to circle back around, reserved instances can give you up to 72% off of the price. This is the one on the far left that we were just talking about. You have to commit to a particular instance if you use standard instances. In other words, you say, look, I want a T3 micro for a year in Virginia, US East 1A. That's a standard instance. You can't change that. It has to stay in that particular region and has to stay that size. If you want more flexibility but less of a discount, you can use convertible reserved instances, which will allow you to merge instances together to make them bigger or separate them apart. But you don't get like the full discount. You can get maximum up to a 50% discount, give or take, for convertible reserved instances. You can modify both of them, but you can modify convertibles a lot easier than you can modify standards. These are all reservations. These are all reserved instances. Now, there's also different savings plans types. This is the bucket of money that I was talking about. You can get compute savings plans, or you can get specifically EC2 instance savings plans. Either way, it's a bucket of money. The compute one can be used for containers and for serverless. The EC2 instance savings plan obviously can only be used for EC2. Notice there's a bunch of savings plans, and here's the main difference between the savings plans versus the reserved instances is that savings plan is a bucket of money, right? And there's different caveats for how they're applied automatically to your compute. But like, for example, notice here that pricing automatically applies to Fargate and Lambda usage, right? The compute savings plans does that for you automatically, right? Instance savings plans also apply to any operating system. They don't care what you're using. That's not true, by the way, for reserved instances. Reserved instances require you to say, I want this OS in this t-shirt size in this location for this duration. So RIs are a lot more inflexible compared to savings plans as far as like saving you money. They all, by the way, have 1 to 3 year options. So moving past reserved instances and savings plans, there's spot instances. This is the one that has the 2-minute warning, because there's this spot price that they offer it at. They'll say, look, normally you'd pay $1 for this. We'll give it to you for 30 cents. You use it for an hour, and then a minute after the hour, someone wants that instance. So you get a 2-minute warning, and then that instance goes away. So you can actually mix on demand and spot into the same kind of fleet of systems. So you can create consistency while still having the cheapest price. Spot instances used to be called the eBay, where you like bid on Amazon's unused infrastructure, but they've changed this a lot. So they actually just tell you what the price is. You don't have to bid anymore. They're like, hey, you can have this instance for $1. Now, ideal workloads for spot instances are basically anything that can withstand interruption. Don't look at this list, right? Anything that can withstand interruption or can be mixed with on-demand instances. So EMR, ECS, batch, EC2, you can mix these systems in with standard stable systems to make sure that 2-minute impact doesn't cause you to fall over. You can kind of see, by the way, is that you can combine certain pricing options. Notice that on demand is basically list price. That's what it says in the upper right-hand side. It says that basically, hey, this is the most expensive way to use AWS. Notice that this one is kind of the cheapest, but can get really add some overhead to your systems. This one, can get pretty like stable as far as like price per dollar or cost per hour. It's pretty like second lowest. Reserved instances, even though they're not as cheap as spot instances, will offer a more consistent discount than spot instances will. So you use these when you know that in a year or 3 years, you are unlikely to change your workload. That's what that's used for. Any questions about reserved instances versus compute savings plans versus spot instances versus dedicated instances? Okay. This one's going to go pretty quick. Note that here, what we're doing is that we typically use this service called EBS, which is Elastic Block Store, and we attach volumes to an EC2 virtual machine because that's where the hard drive storage comes from. They have 5 nines of availability, which is actually really good in a single availability zone. And they are typically a 1-to-1 relationship between hard drive and operating system, like instance, right? These can get pretty fast, by the way. Now we can use them as boot volumes, and they have a life cycle where you create them, then you attach them, then you use them, then you can back them up as well. And then you either detach them and then you can delete them. Now, this is all separate, by the way, from an EC2 virtual machine. You can keep them separate if you want to. Now, there's a bunch of different flavors. The only flavors that really matter that you should be paying attention to are IO2, GP3, and then SC1 and SC1 are really rarely used. These are mechanical platters versus these SSDs. GP3 by far is the most popularly used hard drive in the EC2 ecosystem. IO2, you want to save this one for when you are incredibly, you have a high demand database workload. But for these, I probably wouldn't use these as much as possible. This one is for streaming throughput. This one is strictly for archival storage. That's what they're used for. IO2, by the way, includes an option called Block Express. Just so you know, these hard drives are sick, like fast. IO2 Block Express can get to 256,000 IO per second. That's a lot. That's a ridiculous number. And it operates at 256K per operation. So if you do the math there, it's crazy. These hard drives are way fast, like incredibly fast. But general usage is going to be, you're going to spend your time focusing on those GP3 and IO2 are the volumes you're going to use. One thing that pops up on the exam is that your solid state drives, again, just a reminder, I'm talking about these guys and these guys in particular. The previous generation, I wouldn't too worry too much about. Notice that they cap out at 16 terabytes. This will go to 16,000 IO. This one will go to 64,000 IO. Notice the IO block express will go to 256,000 IO, which is crazy. So 4 gigs a second, which is not the fastest hard drive, but it's pretty impressive for a network-based one. You will have to memorize this chart if you decide to take the exam, but again, only against these guys, right? Not against the IO1 drives. They don't even show up anymore. The STs do show up on the exam, but people rarely use them. Mainly for what they're like, kind of like what they're used for. You'll have to memorize this chart as well if you decide to take the exam. Note that if you decide not to use EBS, you can use something called instant storage, which is going to make your life very difficult, and you're not going to want to use it in production unless you really, really know what you're doing. If of EC2 instance that is using instant storage, if it crashes or is stopped, which it can't be stopped, by the way, this data is all lost. So in general, don't use instant storage. Use the EBS service to attach a disk. If you don't, most of us tend to regret it. So we tend to avoid using instant storage as much as possible. Okay. Any questions on either EBS, the hard drive service, or about the instant storage? Okay, we're going to switch gears because we have 2 more sections to cover, but we also need to stop at 5. So I want you to start the lab and we'll just cover the rest of this tomorrow. The HPC options are actually pretty new. And then serverless is actually kind of a separate thing. So we should cover that tomorrow anyway. That should make sense. Cool. Any questions about any of that? Okay. Ask at any time, but we're going to get hands on. Okay, so if you weren't here before with us, you want to go to webage.quicklabs.com and get logged in to the site. Your labs are already pre-warmed for lab 2. And here's what's going to happen here. You're going to create a VPC. By the way, go ahead and hit start lab if you haven't already done so, just to get it going, right? You're going to create a VPC, create public and private subnets, create an internet gateway. You're going to route traffic, create a public security group, and then you're going to launch an EC2 instance into that public subnet using that security group, by the way. And then you're going to connect to that instance via HTTP, and then connect to the Amazon EC2 instance in a public subnet. And then last few tasks is you're going to create a NAT gateway. You're going to create a security group for your private subnet. And then you're going to end it by launching an EC2 instance as your last thing. And then task 12 has you connecting to the Amazon EC2 instance in the private subnet. And then you have a couple of optional tasks that you can perform. Retrieve instance metadata. So this is a 45-minute lab. So I highly recommend that you go ahead and get cracking on it. If you haven't already hit start lab, please do so. And let's see. Was there anything else to tell you here? Yeah, there we go. All right, so we're going to work on lab 2. And if Any questions come up, I'm not going anywhere. I'll be here. And this is what we're gonna do between now and 5 o'clock. So you get about 45 minutes to work on this lab. Anybody need anything from me before we move forward? Okay, let's do it.